Hey, welcome. I'd like to show a couple things. Here's a nice trick Blue can do. Look at that. She's like a T-Rex or something. Great job. That's the first thing. But the second important news that I have here is that this section is the one where we finally do our Instagram data, where we're finally cloning Instagram. And that's actually an exaggeration. We're only cloning the database. And even then, we're only doing like 7 or 8 tables, not 20 or 50 Instagram tables. But still, we're doing the basics, the important stuff: photos and comments and users and likes and following relationships, hashtags, all that fun stuff, all the relationships between them, and then all those joins. There's a lot of opportunities there. So this is sort of acting as a bit of a end cap on this course. It's not the end, but this is the last kind of data set that we're working with. And then I'm going to show you after this how to build a web app with MySQL. So that's also coming up, which hopefully is exciting. But this section, like I said, is all about Instagram data, really exciting stuff. Gonna basically build the schema. And then the next section is going to be a bunch of challenges and problems with it. Okay, let's get started. Hello, welcome back. So this section is going to be a bit of a capstone. Maybe that's an exaggeration. It's going to be a summary of what we've been focusing on in the last couple of sections. So there's sort of this subsection of the course, the last 3 or 4 sections that we're all focused on working with multiple tables, relationships between data, tables where we have foreign keys referencing other tables, talking about relationships or associations like a one-to-many relationship or a many-to-many relationship, and so on. And then also joins, which is what we were focusing on as of late. So this is going to kind of wrap that all together into something bigger, because so far we've really been working with 2, maybe 3 tables, modeling a single relationship like customers and orders. But now we're going to take something on a little bit bigger. We're going to focus on a bit of a case study. We're going to work with a site that you're probably familiar with, Instagram, and we're going to try and clone the database for some of the basic functionality. So we're not going to be diving into like advertising and keeping track of our users' data and all of that. We're really focusing on the main big entities to a site like Instagram, things like photos and comments and users and so on. So again, we're not really scratching the surface as to how Instagram actually stores everything. We'll talk about what things work best for scaling. We'll run into some fun issues when we talk about how hashtags work and how you should store hashtags. So we will talk a little bit about performance, but this is really more about how do you design a schema for something that has, in our example, at least 7 or 8 tables. In Instagram, the real app, there's probably dozens of tables. But either way, it's a big step up from 2 tables or 3 tables max. And then the other thing I wanted to mention is that in this section, we're going to focus on designing the schema. It's going to be a bit of an exercise, but I'm also going to go through and do it myself. But then in the next section, I'm actually going to give you a bunch of data, like a ton of data. I spent a long time making this here. So this is what we'll be working with. You'll actually be inserting this so that for once we'll be able to work with big amounts of data, thousands of rows, and you'll see the impact that it has. And also, hopefully, it will feel a bit more realistic rather than 2 or 3 things at a time. So that's where we're going. But in this section, we got to create the schema first. We got to understand what we need. So let's start by taking a look at a typical Instagram page. And yeah, some of you may know this. I'm in my spare time, I like to do photography, especially landscape photography, stuff around San Francisco. So I am using my own Instagram here, but that's not really why. I'm not trying to get more exposure or anything. It's just that I don't want to run into any issues with permission or having rights to use somebody's images in my course. Okay, so with that said, the reason this is here, like I said, is not just to show you my photo, but mainly it's to help us understand and identify the key entities. So on this basic Instagram, this is from the web app. Though most people use the iOS or Android app, it's the same entities, the same data. And the first thing, probably the most obvious, is users. So we're going to need some sort of users table or a way to store users. And then moving on, we've got a really obvious one, which are the photos. We need a way of storing images or photos. Now, we're not going to worry about how we actually upload photos and how, what data type we use to store them or anything like that. We'll just say that it's an image URL. So when we actually get to the exercise portion, I'll come back to that. So we need to store stuff about photos. And then we've got things like likes. So we need to store likes for a given photo, but also remember there are some complications because, I can't just click on this heart button, 10 times and add 10 likes. I can only like it once. So we need to have something there as well. Maybe there's something we can do with our database. Hint. And then we've got hashtags. And hashtags are a fun one. We're going to save that for last in this section because there's a lot of ways of doing them. We'll talk about at least 3, and there's a couple of advantages and disadvantages to each. So hashtags, though, are an important part of Instagram and of a lot of tagging in general is a lot of web apps, whether it's blogging or Twitter or something like Instagram. And then we also have other components that I couldn't fit onto one page, like comments here. That's really the big thing that we also need to be able to store comment information. And then there's one other big thing, which is followers and following. So the relationships between users, how do we store that? There's a couple ways of doing that as well. But on Instagram, the way that it works and the way that our database should work is that it's a one-way relationship. It's not like Facebook where, I send a request to someone and we only become friends if they accept, or vice versa, but both of us have to be kind of consenting friends. On Instagram, I can follow somebody and they don't have to follow me back, or people can follow me and I don't have to follow them back. So how do we store that in a database? Okay, so that's really what we're focusing on. There are obviously other things, like we're not going to store profile information. We're not going to store stuff about advertising, like I said. And that's just scratching the surface of what we're not storing. There's a bunch more. But we are going to store information, and I'm not saying these are the tables we need. We may need more tables. We may be able to get away with fewer tables. But these are the entities, the information we need to store. So users, photos, comments on photos, likes for photos as well, hashtags, which will apply to photos. We're not going to worry about hashtags inside of comments, which you can do on the real Instagram. We're not going to do that. We can talk about how, but it just makes it a lot messier. And then also followers/followees. It's kind of difficult to talk about the different roles there, but just relationships or friendships or whatever you want to call it. I just call it followers and followees or followings. So these are the main things we need to store. And the way that I'd like to structure this is I would like you to try and give this a shot. So you don't have to actually, insert data and do a bunch of exercises on your own, but I'd like for you to at least brainstorm how you would do this. What are the tables you need? I'm going to, in the ensuing 6 or 7 videos, go through each table we need and talk about my solution. But it would be great if you would take the time to just kind of think about it, jot it down, either draw diagrams out, create a schema file, and just write the create table statements, whatever you feel most comfortable with. If you want to get a whiteboard or post-it notes, whatever works. But think about how you would do this. If you were creating, it doesn't matter if you're a developer, if you know how to code in other languages or not, but if you were creating an application like Instagram with the functionality we described, what would you sit down and start with for your database, and how would you brainstorm it? So that's really what I'd like you to do. And then in the next couple of videos, I'll step through in bite-sized chunks. I want to make sure that these are short videos, which I know I have said before and maybe have not held up my end of the bargain all the time, but these will be shorter and they'll go through my thought process and how I created it. Oh, and before I forget, if you're going to attempt this, when you're creating the tables that you need to store this type of information, just focus on the core essentials. So for something like users, you don't have to be, have a username and an email and a password and I don't know what else Instagram asks for, like a birthday maybe and a profile and all of that. You don't need that. Just the basics, maybe like username and whatever else you need to have it work or have it relate or associate with all the other entities. It's easy to add the individual things to a table. Like for users, adding an email column is not hard. But then figuring out how you have users connected to likes, for instance, that's what I'd like you to focus on. Okay, so again, you don't need all the information you can possibly think of, just the key parts. All right, so this is the first video of basically talking about the tables we need and implementing the tables we need for our Instagram clone. And the first thing we'll start with is users. Users is a pretty obvious place to start. I guess another one might be photos, but users is at the core of everything if you think about it, because users are connected to, photos, they're connected to comments, they're connected to likes. They're not connected to hashtags, but pretty much everything else relates to users. So what I'm going to do here is something super simple. Like I said in the last video, there's a lot more we could store here. Email, password, like 20 different things, location, city, IP address, all that stuff. We're just going to focus on the basics. So an ID, a username, and a created at. And created at will just be, the day the user or the timestamp when the user signs up. It will have a default value of now or current timestamp. Username is just going to be a varchar, and ID will be a primary key. And we'll be referencing this ID in other places. For example, when we talk about photos, photos will have a foreign key referencing the user ID. So we'll go ahead, and the first thing I have is just an empty directory I made just to store this, and I'm just going to make a new file, and I'll just call it Instagram_clone.sql. I'll open that up, and this is where I'll work. So this is where I'll do a create table, users, and like we said, we're going to have an ID, we'll have a username, and a created at. So ID is going to be integer or just int. I'll do integer just because I've been doing int, but it's an alias for integer. It's good to see both. And we'll have it auto increment, and it's a primary key. Great. Comma. I'll come back to username in just a second. Created at, I'll do timestamp with a default of now. And you could also do current timestamp. And remember, you could do date time as well. Timestamp is just smaller. It's easier to store. Okay, so then we've got username. And we know it's just going to be a varchar 255. There's another constraint that we could add though, which is we want username to be unique. We don't want anyone to be able to sign up with the same username essentially. So we can add unique. And you might be wondering, well, then why would we have, ID be the primary key? Why not make username primary key? You absolutely could do that. But if you're going to have a foreign key somewhere referencing username, and you're working with a long string, if someone's username is, something massive like that, because we could do 255 characters, that's going to be slower and more annoying to search, definitely slower if you have thousands and thousands of entries compared to a smaller integer. So it's good to have a primary key be an integer, but we can still have this unique constraint. And we can also add not null. We don't want anyone to be able to sign up without a username. Okay, I'm going to go ahead and make a new database to put this in, but I'm going to do it in this file. So I'll do a create database, and I'll also just call it Instagram or IG clone. And then I'll use IG clone just like that. So now every time I run this file, it's going to make this database, use Instagram clone, the new database, and create the table. And the reason I'm doing that is just one, to show you that you can. We haven't really seen using these commands in a file. But also, as we go, we may want to rerun this and recreate the users table or another table if we realize we messed something up or we need to change something. We're not going to have any data in there yet, so it's super easy just to create the database again, drop it, then create it, and then use it, and then create the table of users. Okay, so with that said, let's try this. I'm going to do source, and I need to reference this directory /instagramclone.sql. Okay, and just to double check, describe users. That looks good. Okay, so if you are good with that, go ahead and move on. Next up, we're going to talk about photos. But I will spend a minute or two just adding one or two users so that we can work with them in this section. Remember, in the next section, we're going to have a massive data set that I'm going to give you. But if we want, we can just play around with some data. So I'll do an insert into users, and we'll just insert username. And let's just do 2 or 3. So we'll have blue, the cat, and we could also have, I don't know, Charlie Brown. And then I'll just put myself in there, just like that. Okay. So what we could do now, if I resource this whole thing, I'll get an error because it tells me I can't create this database Instagram clone. It already exists. So I could either drop the database first, and I'm going to do that for now. You typically don't want to do that. You don't want to drop a database ever if you can avoid it. But if there's no data in there yet, or if the only data that will be in there is in the same file, like we're doing here, just testing it out, this makes it easy because I can just run this one command. It will erase the database, recreate it, and get all the new tables that I need in there, as well as the new data. So now I can do a select star from users, and there we go. We've got created at in there automatically, ID is automatic, and our 3 usernames. Okay, next up, photos. All right, moving right along here. We're working with photos this time. And the easiest way to store photos is just a single table, photos. But of course, they need to be related to a particular user who created the photos. So we'll have an ID, and all we'll store about an image itself is the image URL, which will just be a string. We could have added a caption as a varchar, not a string. We could have added a caption. We could have added location data. On Instagram, you can say where it was taken. There's all sorts of things that we could do, but we're just focusing on image URL in our case. And then a user ID, very important, foreign key pointing to users.id. And then we also have created at, just like we had with users, just a nice way to be able to, sort photos by most recent to least recent, or figure out the first photo somebody posted, or if one photo is posted before another, if one looks like this has actually happened to me, or people take a photo of mine and repost it claiming that it's their own. It doesn't happen often, but 2 times actually by the same person. And the person actually flipped the image, mirrored it, posted it, claimed that it was their own. But of course I could just show that mine was posted first, thankfully, because there's a date. I mean, it didn't really matter anyways, right? It's just photos on a social network, but still having that created at in there helped me there. So let's implement it now. It's pretty straightforward. We'll just create table photos. We're going to have an ID. We'll also have our photo or image URL, whatever we want to call that. We'll have user ID and then created at. So ID is an integer or int auto increment primary key. We'll be referencing photos.id from other tables because things like comments are associated with a particular photo, or likes are, and tags as well. So we need that primary key there. Image URL will just be a varchar 255, but we should add not null. We don't want that to be empty or to be null. That's a big problem because there'd be no photo to display. And then user ID, that will be an integer. And let's also make that not null. A photo needs to be associated with the user. We can't have an orphan photo that has no user. And then created at will just be another timestamp with the default value of now, the time it's created. But we still need one more piece, which is our foreign key constraint, which is going to pertain to user underscore ID, which is referencing or references the user's table, the ID field. Did I spell that right? Reference, there we go. Okay. And that will create our photos table. So if I just resource this whole thing, now if I do show tables, we have both tables in there. If I do a describe photos, we've got photos there, everything looks good. And just like before, if you want to stick around, I'm going to insert 1 or 2 photos in here associated with our 3 users, but I'm done with creating the schema, so you feel free to move on to the next one, which is comments. But if you want, you can stick around as I do an insert into photos, And we'll just do an image URL and a user ID. Those are the two things we have to supply ourselves. Values, and our first one, let's say Blue submits it, and we'll come back to the URL, but Blue's ID is going to be 1, and if we weren't sure, we could do, select star from users. You can see Blue is 1, Charlie Brown is 2, and Colt is 3. So we'll just do something silly. Let's just say the URL is just random like that. I'll duplicate that a couple times. In Cloud9, it's Command-Shift-D or Control-Shift-D on a PC. And then here's another random thing. This time it's submitted by Charlie Brown. Let's say Charlie Brown has another one as well, like that. Okay, and I haven't submitted any photos. That should work. If we run our source again, this time, so it dropped the database, recreated it, switched to it with the use command, created our two tables, inserted all of this data. Now if we can do select star from photos, and we should have 3 simple photos there with a user ID. We're now at the point where we could do a simple join if we wanted to figure out who posted these photos. So again, definitely if you feel good about this, move on and don't waste time watching this. But if you want the practice, we could just do a select. Let's say I wanted to have the image URL created at and the name, the username of the person instead of the user ID. So we'll just do a select star to start from photos, join, and we'll just do a default inner join, users on, and we're going to do it where photos.userid equals users.id. So if we start with that, there's a lot there, so let's thin it out to just be photos.image URL, comma, users.username. Is that what it is, username? Yes, just like that. Copy it. Okay, and now we can see Blue the cat created that and Charlie Brown created those two. All right, and what I'm going to do just to set a pattern for the next few videos is move these joins and things that I'm just playing around with down to the bottom and comment them out. We don't want those to run, but I'll leave the insert statements here as well as to create tables. All right, moving on. All right, so we're moving on now to comments. And we did users first and photos for a reason. One is that they're simpler and essential to Instagram, but also comments is going to rely on them. Because if you think about how comments work, if we go way back here, these comments over here, this handy green box to draw your attention, are written by somebody, right? So it's not just a comment like awesome or banger, but there's also somebody who wrote the comment. So there's some association there. So a comment needs to be related to a user. But then these comments are related to a particular photo. These comments here are for this photo, not this one, right? So they're not just floating in thin air, but they're also related to a photo, which means we're actually going to have 2 foreign keys. So it looks like this. We have a comments table. Comments will have an ID, primary key. Our comment text, which is just, the text of the comment. I didn't want to call it text because that's a reserved word in MySQL. Even though it might work for you, it's just not a good idea to mess with that. In reserved word, meaning that text is a particular data type. It's something that's used in MySQL in the language. So naming a column in a table is not a great idea. It's like naming a column, integer. Okay, then we've got user ID, which is a foreign key related to the users.id. So that's how we know who wrote it. Then we've got photo ID, which is also a foreign key, this time to photos.id, which is how we know which photo the comment is on. And then we've got our good old friend created at. So let's hop over to Cloud9. I'll do it down here after photos. So we'll do a create table comments. And our main things, we've got ID, we've got comment text, then we've got user ID, photo ID and created at. So we'll start with ID. We'll do integer, auto increment, primary key, pretty standard. Comment text will just be varchar 255, as well as we want to make sure it's not null. We don't want anyone leaving empty comments. If you try that on Instagram, it just won't post it. Then we've got user ID, which is just an integer, but we also want that to be not null. We don't want to have a comment that's an orphan that's not related to a user. Same thing for photo ID. It's going to be an integer, and we also don't want it to be not null, or we don't want it to be null. We want to make sure it's not null, because then we'd have another type of an orphan, a comment without a parent photo. So we have these two relationships here. User and photo are related to comments. Okay? And we don't want either one to be null. And then created at, good old timestamp default now. But we're missing our foreign key constraints. So foreign key, and we'll start with user underscore ID, references, users, ID, comma. Then we've got another foreign key. This time we're working with photo ID, which references, photos ID. There we go. Okay, so just to make sure I don't have any typos here, add my semicolon, and I'm just gonna resource that. If I can find it, here we go. Looks good so far. If I do show tables, I've got comments, and I can do describe comments, and we're good. All right, so just like the last few videos, stop here if you feel good with this. If you want to see me insert some data and see how we relate things when we actually insert the data, I'm gonna do that. But of course, move on if you feel comfortable. So if you're still here, what I'll do is insert a couple comments between or related to these three users and these three photos. And this is where it gets kind of difficult to keep everything straight, keep all the IDs and everything straight in your head. So we'll do an insert into comments, and we'll have comment text. Then we'll start with the user ID, who's posting it, and then the photo ID. Values. So let's say our first comment is going to be Blue commenting on this photo here, saying this is, or how about her comment is just meow. Okay, so that's the comment text. And the user ID is who's saying it. Blue the cat has an ID of 1. And I just, you can tell because we inserted her first, but of course if we went back to our select way back here, you can see, well, no, you can't see there. You can see here, her ID is 1. Okay. And then the photo ID, we'll just say she's commenting on this one here with photo ID of 2. And I'll duplicate that. So let's say somebody else commented. Let's say someone says, amazing shot on the same photo here. And let's say I commented on that. So that would be my user ID 3. And we'll do one more this time. Let's say Charlie Brown is commenting. I heart this. And Charlie Brown is user ID 2. And let's say he's commenting on the first photo that was submitted by Blue with user ID 1. So you can see how it gets a little bit crazy, but we can do that now. And make sure I have my semicolon instead of a comma there. This time, if we source it, everything looks good. We can do a select star from comments. There we go. We've got 3 comments. We could put a user ID in and a photo ID. I won't do that now. We'll do it as an exercise later with some more complex data. But of course, you can do that if you want a little bit of practice. All right, moving on to likes. So we've seen now users, photos, and comments. And likes are a little bit similar. They are like the comment schema because when we think about how likes work, on Instagram at least, you like something, you like the particular photo, let's say, it's corresponding to that photo. We need to have an association there. But then there's also the association between me, the person liking it, and the like itself. And that might not matter if we allowed for infinite likes. If anybody could like something as many times as they wanted, it was a button that clicked and it just kept going every time I clicked it, we could get away with not storing, user information with a like. But even then, it might be nice to see how many times somebody had liked something, or how many likes, in general, how often do I click the like button compared to somebody else? It might help us figure out who's a bot. Like on Instagram, that's a big problem actually, are these bots that people write that go and just like photos, like things all the time, create comments that are just cookie cutter. It's kind of frustrating actually if you're a photographer, because you'll post something and then you get excited that you have 100 people who liked it, and then it turns out a lot of them are bots. If you actually go try and look at them, they don't have any photos posted really. They always comment the same thing. Long story short, in this giant data set here, I actually coded in some bots that we'll be working with. Basically, people who aren't creating much stuff. They're not posting many photos, but they are liking a lot of things and commenting a lot of the same thing a lot of the time. Anyway, back to likes. It's going to look like this. We'll have a user ID and a photo ID and a created at. So our user ID is going to refer to a user's ID, and a photo ID refers to a photo ID. And there's really nothing else, right? There's no information being stored there, maybe, aside from the date or the time it was created, when the like happened. But what else is there to store? Maybe Instagram is doing stuff like whether it was liked from the web version versus the iOS version. Maybe they're storing, other information here, possibly. But for us, this is the basics. We just need a user ID and a photo ID. And every time, a photo is liked by a different user, we get a new like, just like this, with the user ID and photo ID. So we'll start by coding this. You might have noticed that I didn't add an ID to likes. I'll explain why in just a second. But let's start by creating our table. So we have create table likes. And don't forget the semicolon. We've got a user ID and a photo ID and our created at. Let's start with created at. We often neglect it. Timestamp, default, now. Okay, nice and easy. User ID is just an integer. We don't want it to be empty. Same thing for photo ID. But then we need to set up our foreign key constraints. Foreign key, user ID, references, users, ID, comma, another foreign key, this time photo ID, references, photos, ID. Okay, so now let's address why we don't have an ID here. And the main reason is that we don't need an ID. We're not going to be referring to likes anywhere else. If we were, it would be good to add an ID there maybe, but we're not having any table store information about likes. The other thing you might be wondering about is how do we ensure that, there's only one like per user? Is there a way to do that in the database? Because right now, if I did this, I could just insert, let's say my user ID is 1 and a photo ID is 1. I could insert a like with user ID 1, photo ID 1, and then insert it again and again and again. And there's nothing stopping that. So what we really want to say is we want a unique combination of the two. There can only be one instance of every combination. And there's actually a way of saying that. We haven't seen it, but you can do this, primary key, and then we can just say user ID, comma, photo ID. So what this will do is basically not allow you to insert two, likes that are exactly the same user ID and the same photo ID. And I'll demonstrate that. If you feel confident, if you trust me there, you can skip, move on. We're done with the schema here. Let's just make sure that it runs. I don't have any syntax errors, of course. Okay, it does. But if you'd like to see me try it out, like the last couple videos, I'll do that now. So if you're still with me, all I'm going to do is take these photos and these users, and I'm going to have some of them like them. So let's take blue, user ID 1, and that first photo, she created it. That doesn't matter. You can like your own photo on Instagram. So we'll insert into likes. And we have user ID, comma, photo ID. So the first one will be 1, comma 1. So I'm inserting, or Blue is liking this photo. And then let's have Charlie Brown also like it. So that would be a, 2, comma 1. And then we've got the next photo here, which has a photo ID of 2. Not this, remember this is the user ID who created it, but this has an ID of 2. So let's say Blue also likes that one. So Blue ID of 1 likes photo ID of 2, and she likes photo ID of 3. And then let's say I have user ID 3. I like photo with ID of 3. Okay, so let's start there. We run it, it works. There shouldn't be any problems at this point. But now if I try and do this, insert into likes, user ID, comma, photo ID, values, and I do 1, comma 1. Well, that's not that. There we go. 1, comma 1, which already is in there. Blue, user ID 1, and then this photo, add blah, 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 76 with ID of 1. We already have that like. But if I try it, you can see I get duplicate entry 1-1 for key primary. So the way it does it is basically combines the two, keeps track of the combination like that with the dash between it. So that's pretty much it. I will copy what we just did and add a note here. If you're looking at these notes later, just saying won't work because of primary key constraint. And I'll comment it out as well. We don't want to run that every time. Great. And next up, we're moving on to a fun one, which is relationships, following, followers, all that stuff. Welcome back. So we're moving on to capturing the relationships, the friendships between users. So we're talking about followers or followings or however we want to term this. I just refer to it as follows, but it's not really a great term either. But basically, how do we capture the data when I follow another user and they may or may not follow me back? It doesn't matter. I'm still able to follow them. And that's all we need to capture is this one-way relationship. And the easiest way to do it is with a single table that we'll call follows. And all that it is 2 user IDs. So both of these are both of them are foreign keys referring to a user ID. A different user ID that's important. We can't have a user follow him or herself. So they're different IDs. And I called them follower ID and followee ID. You could do, user 1 ID and user 2 ID, but the idea here is that you can tell who is following who. That the follower is the person following the followee. It's a nightmare to try and discuss here. So let me give you an example. Here's our table of users. So we have 3 users, Tommy, Blue Cat, and Cold Steel. And they have an ID of 1, 2, and 3 respectively. Okay, so here's our follows table. And the first thing, let's say that Colt, me, decides to follow Blue. So that means, follower ID is 3, follower being me, the follower. Who am I following? 2, Blue, the followee. But she doesn't have to follow me back. And she doesn't follow me back, at least not yet. If you look next, I'm following user ID of 1, which is Tommy. Speaking of Blue. Yes. Okay. Let's see, where was I? So I, with user ID 3, follow Tommy. Okay. And then you can see now, Blue, whose user ID is 2, finally follows me back. She decides I'm a good owner, and she wants to follow me on Instagram. But the key thing here is that it's a one-way relationship. Here we have, I'm following Tommy, but Tommy does not follow me. And this is all we need, the structure to encode that information. A couple points we should make, that these are both foreign keys created at. It's just good to know if you want to keep track of, when people are being followed. Again, not essential, but it's something that Instagram definitely is tracking, friendship date or something. And then also, we don't want to have duplicated, follows. So I don't want to be able to follow Blue again. So we need to enforce that these are unique. The combination of these two in an order. So as you can see, 3 and 2 is here, and we can have 2 and 3, but we can't have another 3 and 2. Okay, so let's get to it. We've got follower ID, followee ID, and created at. And we won't be needing a primary key ID or an ID integer that is a primary key because we won't be referencing these friendships or follows anywhere. So create table follows. If you have a better name, feel free to use that. And the first thing we have is our follower ID and our followee ID, and then created at. Okay, oh my gosh. Okay, so let's start with created at, timestamp, default now, perfect. Then we've got follower ID and followee ID are both integers. We don't want them to be null. Just copy that on over, put our commas there. And now we also need to officially declare these as foreign keys. So that would be foreign key follower ID references users ID. And we can just duplicate that line and just change followee ID. It also references users ID. And then the last thing, as I mentioned, is we want to enforce that you can only have one of a given relationship. So if user ID 1 is following user ID 2, that can only be in the database once, but user ID 2 can follow user ID 1. Anyway, so to do that, it's just a matter of primary key. And the order that we actually put them in here won't really matter. I mean, it makes a difference to MySQL, but for us, it won't matter. Followee ID. Okay, and so that creates the table for us. Let's just check that everything works. Looks good. Let's do a describe follows. Good. All right. So just like the last couple videos, we're done. If you want, stick around and I'll play around with some data and show you that this primary key constraint is working. Okay. So if you're still here, let's try doing an insert into follows, and we'll have our follower ID first, and then our followee ID. Gosh, it starts to just sound like gibberish after saying it enough times. So let's say that we start off, we've got these 3 users, right? So blue follows Charlie Brown. So that's going to be 1, 2. And we'll also have blue follow me. So that's 1, 3. And then let's say I also follow blue back. So that is 3, 1. And then let's say that, who do we have? Charlie Brown follows blue. Let's say Charlie Brown follows me. So that's 2, 3. Okay. Let's try inserting them. Looks like it works. You can do, select star from users, from follows. Great. We got follower ID, followee ID, and created at. And then the true test is if I try and reinsert a relationship, like insert into follows. Getting sick of this follower ID, followee stuff, but we're almost done. So let's say I try and insert this friendship, 1, 2. So that is blue following, or let's do 1, 3. It's blue following me. She loves me so much, she wants to follow me again. If we try and do that, it's a duplicate entry. But as we saw, you can see here, we already have 3, 1. So if I did do, if I do 1, 2 this time, which we also already have, that's blue following Charlie Brown. It's a duplicate entry. But if I switch the order and do 2, 1, that's permitted because we don't have that in here yet. But now, of course, it's a duplicate entry. So the order does matter, right? Who's following who? Okay, so hopefully that makes sense. We're moving on now to our final piece, which is tags, hashtags. And finally, we've arrived at our last entity to store, which is hashtags or tags. And we save this one for last because, as I mentioned in the intro video, it's the hardest, I guess. Well, it doesn't have to be, but there's a couple different solutions we could go about, and I wanted to have a discussion about which is best, if there is one answer. So let's step through 3 potential structures that we could use. And remember, the way that this works is that one photo can have, 10, 20, 50 hashtags. I do think there is a limit on Instagram. I mean, you can keep adding them as many as you want, but only 30, I believe, actually will show up. Or it's not that they won't show up, but it's that when you search for a hashtag, your photo will only show up if you use less than 30. Anyways, we're getting off track here. But the idea is you can add hashtags to a photo, but then you can also, go click on a hashtag and see all the associated photos with it. So here's one way we could structure it, which might seem maybe the least obvious to you, which would be to do it like this, where we actually just have our photos table, but we add a column called tags, and it's a string, just a varchar that just has our tags, and we could separate them by the hash sign, the octothorpe, or by spaces or dashes or something, but we're just storing them together. And this could work, and places do use this. I've seen it suggested, at least. I haven't seen it in practice. But you can imagine how it would work. To add a new tag into something, you'd basically just take all the other tags and then concatenate in at the end a new tag, or at the beginning. And then you could have an order to, figure out which ones were posted first, I guess, based off of that order that they're in. And it's pretty simple. If you wanted to find all photos that are tagged with cute, you just basically have to use like, where tags like cute. But then, as you can see down here, there are a couple problems. Let's start with an advantage, which is that it's very easy to implement. You don't need any other tables. But there are a couple disadvantages. One is that there's a limit to how many tags you can have in there, which is the length of, whatever the column is. If a varchar, whatever the maximum length is, you can only put so many in there. The other problem, or another problem actually, is that you can't store additional information like, if we wanted to store the first time a hashtag was used, if I wanted to be able to see the first person to use the hashtag, whatever, cat or something, I'm not storing the time that something was tagged because, on Instagram, you can add hashtags after the fact. I'm sure they're storing that when they're tagged so that they can track trends as hashtags come and go. So it doesn't allow us to store additional information like that. And then the other thing that's kind of important is that you have to be careful when you're searching for stuff. So if I was trying to find the hashtag food, and I wanted to see nice food, beautiful food, so the hashtag is just food, well, it will return this, which has sad food, if I'm just doing like food. So I'd have to be careful, and I need to add spaces maybe to make it easier to separate things out. Basically, you just have to be careful. There's ways around it. We've seen them before, how you use search with like. But the point is, this is an easy solution, but it's not going to be the best, and it's not the best for us right now. So another solution is to use two tables. So we have our photos as our photos table currently is now, but then we have a tags table where we have our tag name, in this case cute, and then a corresponding photo ID. So, if this photo with ID of 1 is tagged cute, we put it there. And then a photo with ID 3, which is the selfie here, is also tagged cute. And then photo ID 2 is tagged with microwave, and 3 with ego, 3 with smile, 2 with gross. So as you can see, we can have a single photo with multiple tags, like here, where we have this selfie. ID 3 is tagged with smile, ego, and cute. And we can also have tags that are applied to multiple photos, like cute. It's applied to the first photo and the third photo. So this works. There's unlimited number of tags. That's an advantage. We don't have to worry about how many can fit into the string. But a disadvantage is that, for one thing, we are storing, these tag names over and over and over, and these are strings, and that it's maybe not ideal to store all these different strings and have duplicated data. But it's not a big deal. The duplication isn't the problem. Really what it comes down to is that this is actually slower than the previous solution when it comes to things like inserting or updating or deleting. But then another problem is that it's actually slower than the previous solution. So in just a moment, I can show you a comparison that I didn't do, but there's a great article that I found where somebody does a speed test between these, the three solutions, to figure out when they perform best. So this is not one we're going to use either, but solution 3 is, which maybe you got, it involves 3 tables. So we have our photos table, unchanged. we have a different tags table. So this tags table is just a tag name and an ID. And then we have a middle table, a join table called photo tags or tag photos or taggings or something, whatever you want to call it, which is an instance of a hashtag being applied to a photo. And all that it is a photo ID and a tag ID. And that's it. So in this case, photo ID 1 is my cat is being tagged with cute. And then the same photo, my cat is being tagged with pets. And then we have, we can keep going. My meal is being tagged with microwave. And my meal is being tagged with gross, and so on. So we have these, 2 columns, and that's pretty much it. The advantage, again, just like the previous one, there's an unlimited number of tags, and we can also add additional information. So if I wanted to, when a tag is created the first time over here, I could store the first time it was created. And then over here, every time it's subsequently used, I could store, the time it was used or something. And so I'm sure there's some interesting data you could garner from that, or the location of where in the world it was used or something like that. The time of the day, day of the week, whatever. And we also have less duplication of the tags over here. But then there are a couple problems, and they really come down to just more work. So when we're inserting something, if it's the first time a hashtag's been used and it's not in the database yet, we have to create it, and then we have to associate it with a photo using photo tags. And the same thing when we're updating. We have to... What? She just vomited. Anyway. And then we also have to worry about orphans. We should always all be worried about orphans, but in particular when we're talking about these tables, when we're deleting something, right? If we delete a tag for some reason, which Instagram does, if there's a problem, if something is being misused or somehow being, controversial, they can be removed. And so then we just have to make sure when we're removing it from here, we also need to remove it from all associated photo tags. So it can be a bit more complicated. But basically it comes down to the cost of having this nicer structure is that it's just a little more work. And just as an end note here, I did mention earlier that there is this great article online, this guy who does speed tests of different ways of doing tagging. And it's written up. I'll include the link along with this video if you want to read it. I'll just spend 10 seconds talking about it. But basically, he does some tests here to show that depending on, one, the size of your data set, this example with a smaller data set, the second and third approaches I showed you with multiple tables are actually faster. But then as we get a larger data set with thousands of tags, it actually changes. So it's just interesting to note that and to read. But also it talks about how much time it takes to insert compared across the 3 different versions. And it's just an interesting article. But if you actually look at his conclusion section, which is probably what most of you care about, where is that? Is that he actually thinks that it would be best to have, if you're working on a huge app, to have 2 versions. The first version I showed you and the third version I showed you. And basically they are perform best in different situations. And this is getting into the woods a little bit, but basically the version that we're going to go with, the third one with 3 different tables, is faster if you're working with common tags, things that are used often. But if you're searching or you're trying to do joins with like rare is the wrong word, but uncommon tags that just aren't used very often, then it's actually slower, and it would be faster to do the first version I showed you where you store them as text. So this guy is suggesting to use a combination of the 2, which we're not going to get into, but it's just interesting to note that there isn't one best way, and that it really comes down to your needs, what your app needs, the product needs dictate. And in all likelihood, as an app like Instagram grows, or especially when it started out to where it is now, its schema, its database has undergone multiple big overhauls and changes. Probably not just the schema itself, but the database, whether it's going from something like MySQL to another type database, or a bigger change going from a relational database like MySQL to a non-relational database. So it's really hard to say what's best. But it's interesting to take a look at somebody who's actually crunched the numbers, and even after doing that, can't necessarily give a definitive answer, because the answer is it depends. All right, so this will be a quick video where we just implement the two tables we need. They're both very simple. So tags is just an ID and a tag name. Photo tags is a photo ID and a tag ID. Okay, so here I am in Cloud9, and we'll start with our tags table. Create table tags, and all we need is an ID, which is an integer, auto increment, primary key. And then we'll also have our tag name, which is just a varchar 255, and we want to make it unique. We don't want to have, oh my gosh, if I can spell unique, we don't want to have any duplicates in there. And then after that, it would be nice to add a created at, like I said, so we could store the first time a tag was used or created. And that's it. So that's our tags table, this table here. Now we've got to worry about photo tags. So we'll do our create table photo tags, or taggings, which is also nice, I guess. Well, neither's nice, but also works. We don't need an ID. All that we need is a photo ID and then the tag ID. And those are both going to be integer, not null. There we go. And then on top of that, we need to add our foreign key constraints. Foreign key photo ID is referencing the photos table ID field. Duplicate that. Tag ID is referencing tags table ID field. We also want to make sure that a user can't tag the same photo with the same hashtag multiple times. And that's an easy fix. We just do our same primary key with two items, photo ID and tag ID. And that just ensures that we can't have multiple instances of the same photo tags. All right, don't forget our semicolon. It looks like I'm missing this comma here. There we go. Now if we try that, and we look at our tables, there we go. We've got comments, follows, likes, photo tags, photos, tags, and users. And that's it for our schema. We're done. So in the next section, if you'd like to tap out now, move on to the next section, I'm going to give you a massive file with a bunch of data that I created. It took way too long to do, that we'll be able to do some exercises with and get some practice working with a bunch of tables. But if you do want to see me just insert a couple tags and photo tags, I'm going to do that now. So if you're still here, I'm going to do that. I'll start with inserting a couple tags, and all we have is tag name. And just to verify that, if we go back up to our tags, it's just a tag name that we're inserting. So let's say I'm inserting the string, adorable, and we could have two more, let's say cute, and one more would be, I don't know, sunrise. Okay, so that will insert our tags. Can make sure that that works. Select star from tags. There we go. We've got our three tags. Now we associate them with photos. And so we've got three photos. I'm not, it doesn't matter what they are, but they have an ID of 1, 2, and 3. So if we want to do an insert into, if I spell insert correctly, photo tags, we'll start by taking the photo ID and then the tag ID. Okay, values. And let's say the first photo is tagged with adorable, and the first photo is also tagged with cute because that has an ID of 2. And then we'll say the second photo is tagged with, I don't know, sunrise. And then the third photo is also tagged with cute, like that. Okay, so we can rerun this. Let's do select star from photo tags. There we go, looks good. And now the true test is, can we still insert something that shouldn't work, like a duplicate? We already have, 1, 1. So insert into photo tags, photo ID, tag ID, values 1, 1. And we get duplicate entry. So that's good, works perfectly. But as you can see, the other order works fine. 2, 3 or 3, 2 are not the same thing at all. This is saying the second tag, or this is saying the second photo should have the third tag. This is saying the third photo should have the second tag. Quite a mouthful. All right, so we're done here. Next up, we're actually going to play around with data. Like I said, I'm going to give you a giant file. Hopefully it's fun. And if it's not, well, we're basically at the end of the course. So just hang in there. Hey, welcome to the next section here. This one, we're continuing with our Instagram data. Let's see if Blue will do her trick again. Blue, can you get it? Oh, who's my adorable little kitty? You can stand up like a human. She's come so far. Just like you have come so far. Yeah, so we're working with Instagram data. We set up the schema. Now all we have left is to do stuff with it. So the way this section works is rather than me giving you a bunch of tables, showing you, here's the result I want, we're going to do it a bit differently. I'm going to ask you more of a real world question, like, hey, we're doing a sweepstakes, or how about we're doing a campaign, an email campaign to email all of our inactive users and send them a reminder that they should post. So we need you to get all the inactive users' email addresses. So something like that, where it's kind of in real world terms, not in the terms of a database, like select all users where blah, 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 but you'll have to translate it. So we'll do things like that, or we'll do things like, hey, we have a brand who's really pressuring us to figure out what hashtags are the most useful, or what are generating the most likes. And they want to know what 3 hashtags they should use. So then you'll have to go write the query to find that answer. What are the best hashtags? How do you know? So hopefully that's exciting. Trying to make it kind of a nice ramp off to the real world just for the data section. And then after this, like I said, we have the web app portion of the course. Okay, so lots of exercises, all exercises and solutions in this section. Goodbye. All right, welcome to the next section. So what we're going to do here is basically take the schema design we came up with in the last section for a roughly Instagram-ish application with photos and users and comments and tags and follows and all of that. We're going to take that schema and implement it, and I'm going to give you a bunch of data to put in your database, like a couple thousand of things to enter. I wrote a giant file, and what we'll do is put that in there so we all have the same starting place, and then we're going to pretend that we're the company and we're trying to figure out certain things, like, do we have too many bots on our application? Are there user accounts that are inactive? Are there user accounts that have never posted a photo? Maybe we could send them an email campaign, encouraging them to post a photo. Or what hashtags tend to be most successful, that kind of stuff. So all of this section, every video will be asking a question, which is basically a nice way of saying it will be an exercise. But we're now posing it, rather than me just giving you a table, which is what we've been doing, where it's a table and I just ask you to recreate this. I'm now going to pose the question as if we work at a fictional company and we're trying to find something out. For example, it might be something like, we're running a new ad campaign and we need to figure out which 5 hashtags get the most likes, something like that. So that's how this will work. Every video in this section will be a question, and rather than having all of the solutions at the end, making a giant video that takes like half an hour to go through, I'm just going to break them up. So every video will have the question at the beginning and then a following solution. But the first thing we need to do is insert all of our data. So included in this section is this file here, starterdata.sql, and there's 2 components. The first one is setting up our schema, and there's nothing new here. We talked about all of this in the last section, but if you were following along and doing it yourself, you may have named something slightly differently. Like instead of photo tags, you may have called it taggings, or instead of, instead of followee and follower and follows, maybe you called it following or relationship or something. So in order to give you this data here to insert, I needed to make sure that we all have the same schema. Even if just one thing is named differently, it's a problem. So the first part of this is just a bunch of create tables, all the tables we discussed, as well as dropping the existing Instagram clone database, creating a new database, and then using it. If you want to keep your current Instagram clone database, if you've been working with that, just give this a different name, whatever you want. But you need to do it to all three of these. Okay, so we set up the schema, but then the fun part, which is all these insert statements. And it doesn't look that impressive when you look at it in Cloud9 because it doesn't wrap them onto new lines. And if I start scrolling, you'll see I'm scrolling really fast, but look down here at the progress bar, I've barely made a dent. And this is not a great way to visualize the data. So instead, here I am in Sublime Text, and here's the file that I generated. It's the same exact file, it's just displayed all here. Rather than having to scroll across, I have to scroll down. So, we won't do any sort of grand tour of the data, but I will say this. I spent a lot of time trying to figure out how I wanted this to work. Obviously, I didn't type this myself. I would have taken like days probably. Instead, I wrote some code, which still took probably an entire day and a half to get this how I wanted, because I didn't want just randomized data. If I just wanted to insert a bunch of random users and posts and comments that have no meaning to it, I could have done that pretty quickly. But instead, I tried to design this so that there is certain personas to our users. So some users post a lot, so they have a lot of comments, a lot of posts. Some users are lurkers, meaning that they don't really do anything except look at people, maybe like certain things at best, but they don't comment and they don't post. Then we have things like bots, which on Instagram are a real problem, where bots are accounts that exist basically to go out and like a bunch of things, comment on things, usually the same exact comment, but they don't post things. And then we also have like celebrity accounts who have very few people that they actually follow, but they have tons of followers. And they're not very active with commenting or liking, but they're very active with posting. So then we've got things like hashtags, and I didn't want to just do a bunch of random hashtags. I tried to actually come up with combinations of hashtags that would be common. So, things like smile and style and fashion might be together often, but then we might also have smile and party or concert. Those might go together. Or we might have, landscape and sunrise and sunset and beach could be a combination for a beach photo at sunset. But then we could also have beach with party or beach with beauty or something like that. So that's just kind of scratching the surface, but I tried to design a lot of that in there so that we had somewhat realistic data. With that said, things like comments, the text of a comment is just random lorem ipsum text. So there's nothing there, that's going to be meaningful about the comment itself. What's more meaningful is the relationship between the comment and who posted it, and if they have a lot of comments or they don't have many comments, and that sort of thing. Okay, so that's enough of that. So even with all the effort that I've put in here, there's still only 100 or so, or exactly 100 users, about 250 something photos. But then when we start talking about likes, there's thousands, and comments, there's tons, and following or follows, whatever we called it, there's tons, and tags. There's only maybe 20 hashtags, but then when you apply them to all of those photos, 200 photos, we get thousands too, or thousands of instances. So all you have to do is get that into a file and then execute that file. Let me scroll back over. It'll take too long. Oh boy. Almost there. Here we go. So execute this file, and I'll just do that now with source Instagram / starter data, and that should just be the path that corresponds to wherever that file is and whatever you named it. Okay. So it takes a little bit compared to what we've seen so far. So if you take a look, we've got, a bunch of tables being created, 7, I think, and then a bunch of things being inserted, 100, 257, 7,000, 623, 7,488, 8,782, 21, and then 501. So this is still a very small data set compared to, tiny, minuscule compared to Instagram. This is maybe like a minute of Instagram activity, or probably less than that, a couple of seconds, as far as the number of photos and stuff. But it's still an order of magnitude greater than what we've been working with. One other thing that I'll show you is that we haven't really seen giant amounts of data like this. And if you try and let's do a select star from likes, which I think we have a lot of, you actually, if you start to scroll through it, you'll see that we're not going to be able to see all of them. There is a number that the terminal or that the CLI will print out for us, and then it just gives up or it decides not to display all of them. That doesn't mean they're not there. So if you did a count, for example, count star from likes, we get 8,000. And if you join them with another table, it will join all of them. It just won't display everything. So for some reason you needed to display every single like, it would be better not to do it using the CLI, but to do it from another file or some code somewhere. Anyways, so that's it. We've got the data set up. If you'd like, play around with it, explore it a bit, and then we'll start with our fun challenges in the next video. All right, so we have this data in our Instagram clone database. Now we're going to ask some questions. And the reason I'm phrasing it that way, asking some questions, is because that's usually what you're actually doing. If you work with SQL or SQL, some SQL database or any database really, even if it's like a MongoDB or CouchDB, Postgres, MySQL, any database out there, and you have a bunch of data in there, a lot of the time you're just sticking stuff in there. But when you're actually working with the data and writing queries, a lot of what you're doing is asking questions where you have a motivation. You're trying to figure something out, whether it's for an ad campaign or a postmortem after a campaign. I know I'm coming back to ads a lot. It might just be sales. Like you could be a woodworker, you make furniture, and you want to figure out how much you sold last year because you're compiling your tax returns or something, and you need to figure out the total volume you sold. Those are the questions you're asking. So you think in terms of English or whatever language you speak, you think in terms of questions in a non-SQL language, like how many X did I sell last year? And then you have to translate that to a sum or a select something from something else, and you have to use sum most likely. Anyways, so that's how we're going to work here. And we'll start out nice and simple in this first video. Suppose that we want to reward the users who have been around the longest. So you may have seen something like this on not Instagram, but other applications. You'll sometimes get, a coupon or just a thank you email. Thanks for being loyal over our 5 years or however long we've been around. So all we want to do is reward our users who've been around the longest. And to do that, we need to find the 5 oldest users, the users who have been around the longest. So this one should be simple, not crazy. We don't need to work with many tables. Short video. Try this on your own. Pause the video, of course, and in like 3 seconds, I'll be right back. And I'm back. So to do this, it's just a matter of basically selecting star from users, and then we just want to order them based off of the date that they were created, the date they joined, and then we'll limit it to 5. So if we hop over, what I'll do is make a new file. New file, where are you? And I'll just call it solutions.sql. And in here, the first one is just finding, let me put the numbers here so it's easier for you when you're looking at this, finding 5 oldest users. And we know it's going to be a select something from users. And if we start there, you can see we've got 100 users, which is one thing I wanted to point out. 100 users is not very much, but I capped it at 100 because basically the formula that I imprecisely came up with for how often users are commenting and posting and liking and tagging, it grows exponentially depending on how many users you have. So having 100 users, we still have almost 20,000 records for everything else. And if I upped it to 200, or I tried 1,000 users at one point, it really started going crazy, and our queries take a lot longer. So I decided not to do that. But if you want to try, it could be fun to, if you feel comfortable writing code to insert a bunch of users, do that in JavaScript or Python or whatever language you like. But for now, 100 users. It's just interesting to note how much data we get even with just 100 users. If the average person is posting, X number of times. And then we get certain celebrities who post all the time, not to mention people who are liking all the time. And we get bots who like every single photo. Things quickly grow. Okay, so select star from users, but we want to order by, and our field is called created at, right there. So just order by created at. And if we just do it this way, you'll notice that at the bottom, we have today's date, basically, well, roughly today's date. And then if we scroll up, we've got the oldest one. So we've only been around for a little bit, about a year, according to the data that I created. So what we'll do is just limit 5. And there we go. That's all we need. So nice and simple for this one. I want to start off with some review, but don't worry. If this felt way too easy, that's good. We're going to move on and get into some more exciting / potentially nastier territory. All right. So the next problem here, the next question, is that we're trying to schedule an ad campaign, our own internal campaign that we're going to, well, not internal, but our own campaign where we're trying to get people to sign up, new users on our application. Let's say we're advertising on, Facebook. We're also considering maybe for a single day, we're going to go and put an ad out like on a billboard. We can't afford a billboard for an entire week, so we're just going to do one day. Yeah, it's kind of hypothetical, but still, let's say that's what we're working with. And you could expand that obviously to whatever the budget is and whatever your constraints are. But for us, low budget, and we're just going to run an ad for a day. We want to figure out what day we should do that on, what day of the week is going to work the best. This is something that is definitely relevant, even though it's simplistic here. We're figuring out, days of the week or time of the day. Just as a photographer, that's something that is useful, that people are always trying to figure out is what's the best time to post something on Instagram? What's the worst time? What day of the week is the best? Do you wait, for what time zone do you try and post according to? Do you post something so that people in Europe will be able to see it when they're waking up? There's this whole science, and that's just for photographers on Instagram who are not even really making any money from it. So if you start thinking about advertisers, then that's where it really matters. So we're just doing this simple thing to figure out when users register, but there's all sorts of insights to be garnered about when people are posting photos and how many likes photos get depending on what time of day they're posted and all that kind of stuff. But we're working with this. So what day of the week do most users register on? So we only need to work with users still. So I'm going to just add a comment, most popular registration date. So we can recycle part of this query, select star from users, and we don't really need to order by anything at this point, so I can get rid of that. So what we'll want to do is use a group by to collapse these into similar categories, but we can't do a group by created at because unless somebody registered at exactly the same time down to the second on the same day, group by won't work, and it will just have 100 unique users. So what we can do is basically extract the day of the week, which we've seen how to do that. So let's start with that. Let's just do select username, comma, and I'll do this on separate lines. Username, comma, and then we want day name. This is one way of doing it. You could also use format date, but day name, I happen to remember that one. Although there are all those other methods I don't remember, or functions I don't remember that I've talked about, like the name of a month, I always forget. So sometimes I do end up just pulling open the docs and trying to find the right function. But day name, and then we just pass in created at. Okay, let's try that. Oh, semicolon, before I forget that. So now we're seeing the day of the week. So now all we want to do is group them by those days of the week and then count how many people or how many instances we have for that day of the week. And then from there, we'll just order them to figure out what day is most popular. Okay, so rather than just doing this, we'll add our group by at the end. And we don't want to just do group by created at, like I said. We want to do a group by day name created at. And what we could do is just assign an alias here. So we'll just call this day. And then we can just say group by day. Now if I do this, I only get 7 results. Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. And of course, that's not all the data that's there. That's all that's printed out because these groups have been created. And we can work with them behind the scenes or underneath the surface. So what we'll do, we can get rid of username at this point. We don't care about that. We're going to just group them by day, and then we're going to add our count star, just like that. And let's see what we get. Okay, so you can see it's a pretty even distribution. Let's go ahead and sort. So we'll do an order by day. Whoops, we don't mean day. That's ordering alphabetically over here. What we want to do is order by count star. So I'll give that an alias as well. I'll call it total. We want to order by total. All right. And of course, if we wanted to, can change the order. Technically, the question we're asking is what's the most popular day? And well, we actually have 2 days that are tied for that, Thursday and Sunday. Now, this data is not relevant to the real world. I have no idea. Actually, I'm pretty sure those days are not the most popular. Last time I looked into it for my own purposes, I believe it was the middle of the week, like Tuesday and Wednesday, roughly late afternoon, early evening Pacific time, like 5 p.m. Pacific time was the best time. I'm not sure why. But again, I didn't create this data to be realistic. I just tried to come up with something that would be interesting, whether or not it actually applies to the real world's rules. Okay, so what we could do is, limit it at the end. If we just limited it to 1, it gives us Thursday because it comes first. We could do limit 2 as well. All right, and this is a good time to mention that for most of these things in this section, there isn't only one way of doing it. Sometimes there really is, but often there are a couple different ways of approaching things. And if you feel like you came up with something, whether it's just different and you're not sure if it's better, or you feel like you did come up with something that's more efficient or cleaner or that you prefer, absolutely don't hesitate to post that in the discussion for the course, and we'll do our best to get back to you with feedback on it. But at the very least, other students will be able to see it, and maybe somebody else came up with the same thing and they won't feel so alone in the world. Or maybe you did come up with something better that is actually going to benefit other people to see. But for now, this is how we're doing most popular registration date, and that answers our question. Apparently, we should be doing our registration campaign to get users to sign up on a Thursday or a Sunday. All right, welcome back. So we're moving on to our next question here, even though this one actually isn't framed as a question. There's no question mark, but that doesn't make it any less relevant or less real world. In fact, this is one that I think is a really common operation, a common question to ask, and it has to do with inactive users. So across any sort of startup or online app company, there's often, users who sign up, create an account, and then do nothing. Whether it means never posting or never buying something, never converting from a free account to a paid account, like in the case of Spotify, or never, in my case, this is a real example from my courses, students who sign up and then never start it, never make it past the first video. They're at 0%. And I'm actually able to send targeted, I think once a month, twice a month, I can send an email update, and I can target that to specific segments. So if I, updated an introduction section to a course and I only want to let students know who haven't started yet, I want to target them and say, hey, by the way, I noticed you haven't started yet. Well, this is a good time to start. I just revamped the whole intro. I could do that based off of what we're going to be doing here. Of course, our data and our database is set up differently, but it's the same idea. So this is a really common thing. And all we're going to try and do is, for our Instagram clone, our fake Instagram, we're trying to identify users who have never posted a photo. So they've signed up, they never posted anything. And we want our users to be more engaged for a bunch of reasons. We want higher engagement in our app, which means that we could, have higher valuation potentially, or sell ads for more, maybe get higher investments, all that kind of stuff. We want people posting if they're signed up. It looks bad to have dead accounts, people who sign up and then give up. So we're going to try and send an email. We're not worrying about doing that, but how are we going to target these people who have never posted a photo? First step, let's identify them. And essentially, we're going to need to work with the users table and the photos table. So I'll add my 3 here, which is identify inactive users. users with no photos. Okay, so you've probably gathered we need to do a join. We're going to be working with the users table, so we can start there. Select star from users, and we have 100 something users, but we can't see who's done what because we have the photos table. And if we do our select star from photos, just to jog your memory, well, I guess we haven't actually seen all of our data here yet. We've got exactly 257 photos, but a lot of them are done by the same user. So this here is user ID. If I scroll way up, here we go. We can see, these are all posted by the same user. So 3, these are all from the same user. These are all from the same user. But then we have some users who haven't posted anything. But there's no way of knowing that just by looking at the photos because these are the posted photos. So what we need to do is join these two together, and hopefully you know what we need to do. If I just do a regular inner join photos, and where do we want to do it? We want to join on users.id equals photos.userid. And if we run this now, it's a mess. So let's focus on just the things we need. So rather than star, we can do username, maybe the image URL, and we can just start with those two. All right, so we can see, all these usernames and what they've submitted, but the problem here is that this doesn't account for the people who haven't submitted anything. So if there was a user who didn't submit something, they're not showing up here because we're doing an inner join, which remember is the intersection of both circles, the left and the right, where they overlap. But what we want is to identify where users on the left have no overlap on the right for photos. So we can change this to a left join. And that one change, if we rerun this, we'll have to scroll a bit. There we go. You can see we have certain users who have a null over here. And that's referring to the fact that they have no photos corresponding to them. So there's a couple of them as I go here. And that's what we want to be able to identify. So we're almost there actually. All that we need to do is only select the users that have photos of null essentially. And of course, if I go back to having star here, it's not just image URL that's null. It's everything in photos. It's hard to see. Here's an example. But we've got a couple of nulls here. We've got the image or the photo ID. We've got the image URL. We've got the user ID of the photo. And then we have the created at is null. So all 4 things are null. We just need to focus on one of them. It doesn't matter which one. So I'll go back to just adding username here. And we can do, it doesn't matter really. Let's do image URL again. And then all we want to do is add a where down here. But we can't just say where photos dot, we could just do ID equals null. That doesn't work. Remember, null is weird. So we need to do where photos.id is null. And this could be anything on the photos side. It could be photos.id, it could be photos.imageURL, photos.userid, any of them. So I'll just do it as ID. And if I do this now, you'll see, and we actually don't even need to display the image URL. But if I do that, this is our list of users who have never posted anything for whatever reasons. Some of them, programmatically, I created them as bots, which all they do is go comment and like other people's photos, but they don't post anything themselves. And then another persona of a user is a lurker, which is somebody who has an account and they don't use it all that much, but they just kind of look at people's photos, maybe like something, but they definitely don't post and they don't comment. They're kind of a silent member of the community. So we get a decent number of them. Sorry for that fire truck. And that's all we need to do. If we wanted to figure out how many, that's another thing. We could just add a count in, but we just want the username so that we can target them. These are people who have never posted anything. And just a note, if you did this the other way around, it would have worked just fine as well to do photos, users, and then a right join does the same thing. So either way works, but the key thing is that we're working with null, where we have an intersection where some users and some photos overlap. Most of them do. But then we also have that subset of users who have no photos, and we need to also join those with null, which is how we're able to tell if they have no photos. So here's my solution. If you came up with something different, post it and we can discuss it. Moving on. Alrighty, welcome back to our next riveting installment of asking random questions about our database data that we inserted. Yeah, that's what we're doing here. So our next question here is basically, I'll start the other way around for once. What we're trying to do is figure out what is the single most liked photo in our database. And I actually don't know if Instagram has done this before. I know third parties have. Like people have used the Instagram API to try and find the most popular Instagram of all time. That's essentially what we're trying to do. Let's say we're running a contest is the backstory I came up with, but this is something that just might be nice to know internally at a company like Instagram. Who is responsible for the most liked photo of all time, or the top 10 most liked? Is there anything in common, or even the top 1,000? What ties them together? We're doing just one, and we're not just trying to find the photo itself, but we want to know who posted it, who's responsible for it, so we can send them whatever their prize is, or we can mention them in a blog post or something. So the first thing we need to do is just find the most popular photo to start, meaning the most number of likes, and then we can worry about the username and the user afterwards. So we'll do for identify most popular photo and user who created it. Okay, so to do that, it's going to be a select. We'll do a select star to start from photos. And if we just start there, we have, 257, but no information about likes because that's a separate table, of course. If we do our select star from likes, we have 8,782 likes. And they're not all displayed here for us to see, but we've got two fields. We have the ID of the person who is liking, the liker, and then we have the ID of the photo that is being liked. So what we want to work with is the photo ID. We don't care about who is doing the liking. We care about, matching the photos with the likes that correspond to them. So that's going to be a join, and it will just be an inner join likes on, and we'll do where likes dot photo ID equals photos dot ID. So this is going to be, a big table here. Oh, what's my error here? Extra semicolon. Try that again. It'll take a moment. We've got, 8,782 rows, but just like we did with likes, but this time the rows are significantly larger. We have a bunch of data. We don't need most of that, so rather than just selecting star, which gives us too much information, let's whittle it down a bit, and we'll just do, photos.id and photos.image URL, comma, and then what do we have on the likes table? If you remember, to go over to our schema here, likes is very simple. We just have our user ID and our photo ID, so we'll just do, well, we can do both. Well, let's just do likes.userid to start. And you can see, all right, so this is all, on our last photo with ID of 257. All of these are likes for that photo. And they are all, by this user, or they're by different users. User ID 3, 5, 10, 12, 14, 15. We don't need that bit of information. I just want to show you just so that you can tell we're getting something from the likes table. Now what we want to do is figure out how many each photo has. So we're going to need to do a group by. And before I do that, let's just space this out nicely. Okay, and we're going to group by. We could do the image URL, but it's much easier just to do it with the integer of the photo ID. So group by photos up here, .id. Now if we do this, we have 257 rows now because we only have 257 photos. And then over here, this is still just displaying the first ID of the user who liked that photo, so that's not relevant. What we actually want to do is display the total number of users who liked it. And that's just a matter of a simple count. Now that we've grouped them by photos.id, And now you can see over here, we've got photos that vary. Some of them have a bunch of likes, some of them not so many. Now all we want to do is find the number 1. We could use maximum or max. I'm just going to do a limit 1. For that to work, we need to do an order by. So let's actually start with the order by. And we want to order by count. So I'll give it an alias. I'll call it total. Order by total. And by default, that will be ascending, which is not what we want, right? We want the opposite. Getting there. Okay, closer. Then finally, what we want to do is limit it to 1 and move our semicolon. Okay, so that gives us the name, the ID and the image URL and the total number of likes for the photo, the single photo that has the most likes, which for us is 48. And this is the image or the photo. Now we want to figure out who it belongs to, who created it. So we could do a separate query. We could even do a subquery if you wanted to. But the easiest way is to do another join. So I'll go ahead and show that join. Basically, all we need to do is get the user information in there as well. And so we're just going to do another inner join, this time on users. And we're trying to connect it where not the likes.user_ID. That's the ID of the person who liked it. We don't care about that. We want the photos.user_ID equals users.id. And now you're not going to notice anything right away because we're not displaying it, but we are joining all the user information. And all that we really want is username. So now if we run this, you can see we get Zach Kemmer 93 with ID of 145 is a person who is responsible for our most popular photo of all time. This photo, Jarrett.name, is our URL with a total of 48 likes. All right, next up here, this one will be nice and short. All we're trying to figure out is how many times does the average user post? So we have a board, or our investors want to know basically what our engagement is like, just in general, for every user, any user, how many times can we assume they've posted? So this is just across the board, and really all we need to do is take the total number of posts, photos, and divide it by the total number of users. And you could do that separately in different lines, or you could, do a big join statement between users and photos, and then use average and calculate average. But you could just do it using subqueries, which is what I'm going to do. So something a little different. So we'll just do calculate average number of photos per user. So what we're looking for is total number of photos divided by total number of users. And the first part, well, each of those parts individually, we know how to do. We can just do a select count star from photos, and that will give us the total number of photos. If I add a semicolon, 257. And then for users, I just need to change that to be users. Select count from users, and we get 100. Now, if you're good at mental math, even if you're not, it's easy to figure out our average in your head. But of course, we're trying to do this dynamically so that if we have X, 10,000 more users tomorrow, this still applies. So using subqueries, basically what I can do is divide these two. So I can't just do this. I'll get a syntax error. What we need to do, like we've seen before with subqueries, is add parentheses around these two things. Okay, but even that won't be enough. What are we missing? Well, it's just like we can't just say 5 plus 5, or we can't just do 1 divided by 2. We have to say select 1 divided by 2 in order to get anything. So we need an extra select up here. Yeah, it's kind of a mess. We could do this on separate lines maybe. I'm not actually sure how to best format this because it's kind of a weird query. But maybe something like this. Well, we can leave it at that for now. And I'll comment that out. And now if we run this, we'll get this massive line here, but 2.57. So every user has or on average, every user has 2.57 posts. That's thrown off significantly for a couple reasons we'll see later. There are bots and users who just don't post anything. And if we tried to get rid of these bots, our average would change. So we'll get there in a moment. What we could do is just add in simple alias. We'll just call it as average, AVG. Okay, and there we go. So that's the answer to that one. If you came up with another way, feel free to share it, and we'll talk about it in the comments. All right, moving on. Okay, so next up, suppose getting the brains of our Instagram clone application employees, and we make money by having sponsored content, by having advertisers post things on our app, and they want to know what hashtags they should use, which are most popular at any given point. So what we want to do is just find the 5 most commonly used hashtags so we can tell our advertisers, these are the hashtags you should use on your own stuff because they're trending right now. It's what people are looking for. So to do it, it's pretty straightforward. We have a single join. We're basically going to connect hashtags or tags with photo tags. Remember, we have those 2 tables. The one table is just the name of the tag, and the other table is every time the tag is used and applied to a photo. So we want to count, basically, we want to group all of those photo tags together, count them, but then we want to find the associated name of the tag. So let's start that. We'll do 6 most popular hashtags, 5 most popular hashtags. So if we start with just selecting star from tags, as we've seen before, it's just a list of the hashtags themselves, and then, an ID, a hashtag, name, and then created at. But we've also got photo underscore tags, and we've got a bunch of those, 500, and each one is just a hashtag or a tag ID, and then a photo ID that it's being applied to. See if we can get to the top here. Here we go. So the photo ID 14 is being tagged with whatever has tag ID 1, which is sunset. So photo 14 has the tag sunset. So what we want to do is we can start, if we wanted, by just focusing on these and counting how many times each tag was used, but it makes it a little easier to follow if we join tags, so we have a name of the tag as well. So we'll do that. We'll do select star from photo tags, and then we'll do join tags, get rid of the other stuff here, on photo tags dot tag ID, which is this, where this tag ID equals tags dot ID. So now what we see, there's a lot of stuff, 500 rows. If we go up to the top, we can see they're already being grouped roughly, not exactly, but they're being grouped roughly by the tag name. So we've got, 14 was tagged with sunset, 21 was tagged with sunset, 45 was tagged with sunset, and so on. So then what we want to do is basically collapse them using group by. And we could use the tag name to collapse them, but we could also use the tag ID, which is easier because it's just a simple integer rather than having to work with strings and text. So we'll do the tag.id. So that's group by tags.id. Now we do this. We're getting closer. Now we only have 21 because they've been grouped together. Then finally, rather than selecting star, let's select the tags.tag name, comma, do these on separate lines. We want the count star. Okay, so we can see things like sunset was used 19 times, photography 16 times, sunrise 17 times. Then we'll go and give this an alias as well. We'll just call it as, what's a good one? Total. Okay. Next up, we want to find the maximum. So you could use max, but what would be better, what I'm going to do is just use order by and then limit, because we want the 5 most popular. So actually you couldn't use max because we want 5. So we'll do order by. What are we ordering by? This count here, which we called total. Order by total. And if we do that, it will be in ascending order. So we want to change that. And then we want to limit it to 5, and that should do the trick. And there we go. We see that the top 5 tags right now, number 1 by far is smile. Apparently it's very popular. And we've got beach at 42, party 39, fun, and LOL. And I know for smile and beach, I kind of engineered to be there because when I was making the data, I wanted some hashtags that could be used in multiple contexts, and things like beach could be used in a landscape photography shot alongside sunrise or sunset or landscape, but it could also be used like in a model photography shot alongside model or beautiful. It could be used in a party, alongside a party hashtag if it was a beach party. Smile can be used in a lot of ways, so can party. So anyways, I tried to come up with certain tags that could be used in different ways. And there we go. Those are our top 5 hashtags at the moment. Next up, you guessed it, something else. All right, next problem here. This is a little different. So as I mentioned earlier, a real problem on Instagram are bot accounts that basically exist to go around and like a bunch of stuff or to comment on people's things, but not create their own content. They're not real people. Oftentimes they're commenting the exact same thing. Or like if I post a photo, I'll notice I get like 10 likes immediately, like the next second. And usually there's not 10 people who are happening to like it immediately. There's some sort of program that's happening behind the scenes where it's looking for new posts and liking them immediately. So in our hypothetical Instagram clone, we have the same problem. So what we want to do is just find all the users who we think could be bots. They're users who have they're users who have liked every single photo on the site. So if we have 257 photos, they've liked all of them. If we have 800 photos, they've liked all of them. And I'm going to show you a way of doing it that actually uses something we haven't seen yet, something new. So go ahead, give it your own shot, and then we'll have a solution. Okay, so the first thing we want to do, we know it's going to be a join between users and likes. So we can start with let's do select star from users. And we'll do an inner join likes. And the reason we know it's an inner join because we don't care about users who don't have any corresponding likes or likes that don't have a corresponding user. Those shouldn't exist. So we want the inner join. We want the overlap only. So select star from users inner join likes on users.id equals likes.userid. And if we start with that, takes a moment. We've got, remember, 8,782 likes. And now what we want to do is group them based off of the user who did the liking. So we'll have a group by, and we have a bunch of choices of how we group them. We could do users.id, or we can do likes.userid. We'll save. Okay, so now we have 77 rows here, and we can see, there's a bunch of information. We've got the username. We don't need created at, so let's slim this down a bit. Let's do select username, user ID, and we'll just keep it at that. Okay, so these are all the users who have liked anything at all. We're grouping them, right? So they're grouped by user ID. I'm missing a comma. That's what's going on. Now what we want to do is figure out how many. So that's just a matter of using count star, which you should feel pretty good about now. We'll give it an alias right now. Okay, and we can get rid of user ID as well and just do username. Okay, so we can see that we have Andre Purdy85 has 94 likes. Let's give this actually num likes. But the question was not just to figure out who has the most, but to figure out the people who have liked every single photo. And if you don't remember how many, we have 257, but we're not talking about cheating. We could cheat if we wanted to check exactly for 257. It's not too bad, but you might think you could just do like a where num likes equals 257, but that won't actually work. And that's because where clauses actually go before the group by, telling it what the data you'd like to select to group versus what you'd like to select from the group's data. So where doesn't work. We need to use something different, which we haven't seen, which is called having. And having acts like where. It's just a different word. And what it will do is take our group's data, our end result, and allow us to filter based off of a clause. So we can say having, and we want to say total equals 257, just like that. So now if we do it, total, I changed the name to num likes, but now if I do it, you can see, okay, these are the people who have liked it 257 times, liked every single post. But the problem again is we hard-coded 257. So we could fix that very easily. We want this to be dynamic, however many photos we have, and we can just use a subquery to select count star from photos. So this will be where the number of things they've liked is equal to the total number of our photos. And there we go. We get the same exact thing, but this time if I add 1,000 photos or remove 10 photos, this will still always be the total number of photos. Okay, kind of an ugly query with this subquery here, but if you came up with something different, post it, we'll have a discussion. Hey there. So this section is all about Node.js, and the core of it is how do we take a programming language, any language, PHP, Ruby, Node, Python, any of the other ones out there, and how do we combine it with MySQL so that we can do things like build web applications. And in this section, we're not getting to the web app just yet. So for a lot of you, I know that building a web app has sort of been like the, whatever you call this thing, the catnip, I guess, or the toy that has been dragging you through this course, getting you through the more dull parts, knowing that you'll see how to make an app at the end. But remember, this is not a web application course. This is a course on MySQL. So it's just a small part. But if that's what it takes, it's the light at the end of the tunnel, well, we're basically through the tunnel now. And like I said, in this section, we're not building the web app just yet, but we are seeing how to connect MySQL to another language. In our case, it's Node.js. And so what we're going to do here, it's a tricky situation for me because I don't have the luxury of teaching everybody Node and teaching all the basics that you need. So we're kind of going to do a crash course at the beginning. Then we're going to work with a file of JavaScript and connect it to a MySQL database so that we could do things like randomly generate 500 users and insert all of them with one go. So we can insert 500 users manually, but how could we make 500 random users every time I run a file? That's what we're doing. And then in the next section, we'll build a web app to connect to our database. All right, we're almost there. Alrighty. So as I mentioned in the previous video, this section is a big turning point, and hopefully you're excited about it. I'm excited to teach it. We're going to go from what we've been doing for the last 12, 13-ish hours of content, basically working with MySQL on its own, querying a database, and getting a result printed back to us immediately, which is great. But we're going to go from that to creating applications with MySQL. We're not going to learn how to create complex video games or crazy iOS apps. We're focusing mainly on web applications, but the ideas are the same. I'm going to show you how you get an external language like JavaScript or PHP or Ruby to talk to MySQL, and we'll build a couple things with that. Now, let's quickly review what we've done, not the entire course, but the way we've been working and talk about the merits of that. So we've been working with the CLI mainly, having a database of users or books or whatever it is and asking questions, selecting sales data or orders data or customers and trying to figure things out like, how much did we sell last week or what day of the week was our best selling day across the last 2 years. Those are really important and valid and just common uses of MySQL. So there is this whole subset of creating applications that we're diving into now, but there are tons and tons of jobs, lots of people who, when they work with MySQL, all that they do, not to diminish it in any way, because they can write some pretty complex queries, but they're working with only MySQL, and they're opening up the CLI or they're writing SQL files like we've seen, and they're just saving and running those files. So they want to see, okay, what was my commission that I made in the last year? Calculating tax whatever information, summing a bunch of information in these tables, or doing a complex join to figure out which promotion worked the best. Those are really important and common uses that people do all the time. So it's not just about building applications, but we've seen that first part. We've seen how to do that. We've worked with tables. We've been writing lots of selects, inserts, updates, deletes, all of that. Now we're going to see how we work with other languages. So now it's time for MySQL plus any of these. Pick one. And the reason I'm even showing you this page is not to intimidate you, not to make you think you need to know all of these. You only need one. So depending on what you're doing, there are strengths and disadvantages to certain languages, but really all of these will work. They all have ways of communicating with MySQL. So if you're someone who is comfortable with a language, like if you grew up working with Java, or you took a Python class in college, or whatever it is, you can find ways, I'll talk about what they are, of connecting MySQL and whatever language you're comfortable with. The one we're going to work with is called Node, Node.js. It's getting very, very popular. It's been pretty popular for the last couple of years. Very versatile language, lots and lots of users, great documentation out there. Now, we could have also gone with PHP. Some of you may be wondering about that. PHP and MySQL historically have been a bit of an item, a couple that were spotted together all the time. In the next video, I will talk a bit about PHP. It's totally optional, but I didn't want to bog you down in this video with it. But there are a lot of opinions out there. I'll give you a 10-second preview. A lot of people think PHP is dying. It's certainly in decline compared to where it used to be. It used to be the king of programming languages on the web. Now there are lots of competitors and people are leaving PHP. That doesn't mean that it's a bad language. There are problems with it. This is my opinion as well. There are problems that other languages have been able to solve better. However, there's a big user base out there. Yes, it's not growing as fast every year, but there are still millions of people using it. So do not shy away from PHP if you're comfortable with it. If you want to use it, there's lots of examples out there. But I didn't want to make this course just another PHP and MySQL course. There are dozens. They're getting dated, but there are dozens of them, even on Udemy. Lots of MySQL and PHP. So I chose Node, and I'll talk more about why in this optional video coming up. Basically, JavaScript is the most popular programming language for the web right now, and Node uses JavaScript syntax. And just generally, Node is a great choice. And I could have gone with any of these, although I probably wouldn't have done any of the C languages, but Ruby or Python would have been equally good choices. However, I went with Node because, honestly, that's what people want to learn right now, and it's what a lot of the jobs out there are for. Okay, so that's all I'll say about that for now. Like I said, any of these will work. The next thing I want to talk about is how do they work? What do they do? So we pick a language. We're working with Node, but then what? What's the point of using a programming language? How does it talk to MySQL through external code, and what kinds of things would you do? So here's a little diagram. Imagine that there's a web application. My computer, when I go to, this is hypothetical, Amazon.com, I hit enter. A request is made, and I labeled this as Node.js. Amazon does have some Node in their stack, but this could be any language, so that doesn't matter. But I send a request. Hey, Amazon, can you give me your homepage? Or can you give me my personal profile page? I want to update my email address. How about that? And then the code, whatever it's written in, is going to talk to MySQL. It's going to say, hey, MySQL, this user with the email of colts@gmail.com is trying to get his profile page. I want to select all information related to select everything from users where email is colt@gmail.com. That query is run, so from Node or whatever this is here to MySQL, and a result comes back. And it could be, I'm sorry, there's no users table. I don't know what the heck you're talking about, Node. Or it could be, okay, here's the 5 items in that row about Colt. And then that comes back. So that's kind of this two-way street. And then whatever the programming language is here is then going to compile whatever's sent to me. So the Amazon homepage. So it's going to take all those results and it's going to build a web page for me and send it back. Now, this is not a course on web development. I have another video where I talk about what this course is and isn't and how I'm going to go about covering things like HTML and CSS. I'm going to cover them, but not in a ton of detail because could take hours. I have a 45-hour course on that content. So this is really more focused on the MySQL part of things, which makes sense. It's a MySQL course. Okay, so with that said, I missed the last arrow. Something is sent back to a computer. So it's this cycle where there's kind of three entities. There's a device over here, my computer. It could be an iPhone or Android phone. It could be, I don't know, it could be a smoke detector. It could be a Nest camera. If you have ever seen Nest cameras or any like web-based security camera, I'm not saying they work with Node and MySQL, but there's some database somewhere storing information, and there's some app somewhere running that is listening, that's getting videos sent back or updates from a smoke alarm. Or it could be a virtual reality headset. It could be anything really, any sort of device, another computer, a phone, something else. And then this here, like I said, doesn't have to be Node. That's what we're working with. But you could easily replace that with another language, PHP or Ruby. And then, yes, you could have a different database, but that's not what this course is about. But you could, have a virtual reality headset that's working with Ruby, although that's not a great game development environment. Maybe you're working with Unity and you're writing Java or something, but then you're working with another database. It could be anything, MongoDB, Postgres, or MySQL. The core idea is the same. Okay, so that was a lot of talking. Like I said, there's an optional video coming up about PHP versus Node and other languages. It's mainly my opinions, but there is some interesting data to take a look at. If you're curious about how I came to the conclusion I came to, I spent a lot of time thinking about how to teach this. And what I'd like to do is add kind of alternate versions of what we're going to build here and build a Ruby version so you can see it, and then build a PHP version and build a Java version so you can compare it. But that will come later. This is, I made a decision, and it's an informed decision, and I'll explain why if you're curious in the next video. And then after that, or you can skip right to the next video, which is going to be introducing the project we're going to build. All right, so I'll start this video off with a quick anecdote, stupid story. I have a course online right now. It's done relatively well, a lot of students, and it focuses on a bunch of technologies, including HTML, CSS, JavaScript. We talk about Node.js as well, talk about MongoDB, and a bunch of other tools that go along with them. And at least a couple times a day, I get comments or questions or people demanding that, it should cover PHP or it should cover Ruby, or why doesn't it cover C or Java? And those are valid questions, right? People have reasons for wanting to learn different things. So I'm not trying to diminish their concerns, or, I'm not trying to say they shouldn't want to learn those. But there's no way that any course can teach all of those. And there's no reason that it should, because like I said, you only need one, maybe two. So the reason I bring that up is that it's kind of a contentious thing. People, especially students, when people are learning to program, it's overwhelming. Everyone tells you to learn something else. It's very confusing. Do you learn something that's easy to learn because it's easy to learn? Or is it better to learn something that's popular and more people are using, even if it means that it's tougher? What's the best route? And I think the answer is there's a different way for everyone. It's kind of a lame cop-out answer. So when you're making an online course, you have to decide. And what I decided for this course is we're focusing primarily on Node, and the typical kind of conventional choice would be PHP. So I want to talk about why I made that decision. And the first reason is that I personally am not crazy about PHP. I've done some work with it, some work with WordPress. It, like I said, used to be very popular. There's still a lot of people using it, but it is no longer the reigning champion of programming languages on the web. Like 7 years ago, it was. That was the language that you used if you wanted to make a web app. But nowadays, there's so much more competition. People are writing things in Node, or they're writing them in Ruby, and tons of other languages, Scala, Clojure, all these different languages that you could use. And they all have benefits, right? They all have they came later. They were able to see what worked, what didn't work, where problems were with other languages. They all kind of try to address different things. So I won't go into a lot of the technical details. There's an interesting article online, is PHP the most hated programming language? Not that that is an excuse to not use it, but it's interesting. I'll link to it if you want to read about it. It basically talks about how PHP got so popular back in 1995 is when it started, and then where does the hate towards it come from? And largely, the consensus, at least, is that PHP was kind of cobbled together. It wasn't a consciously crafted, as this says here, programming language. Things were added over the years. And there's inconsistencies, there's some security issues, but you could actually say the same thing about JavaScript, which is a valid criticism, that it was created in, I think it's 9 or 10 days, kind of as an experiment. It wasn't some crazy planned out language, and things have been added over the years, and they're constantly kind of updating the specification for JavaScript. So that's not necessarily why I chose to not teach PHP and choose Node and JavaScript instead. It's really more about the data that's on this page. This is from 2016. It's a Stack Overflow survey they do with how many? 56,000 coders who answered the survey, and there was 45 questions. So if we scroll down, I'm going to click on Technology and go look at the Technologies tabs. We can quickly see, first of all, SQL, very popular. Good news. And you can see here we have PHP, which is in 2016 around 25%. If we go back to 2013, notice that it started at 35%, then went down to 28%, then up a little to 29, and then down to 25, to the lowest it's been. So you can see there are charts online that I couldn't find any that were copyright free, essentially, that had a license that I would be able to show you the image, but there are charts online. You can see the decline. It's not a very steep decline, but there's a decline. And at the same time, if we look at Node.js here, which was at 7.5%. Now it's going up to 9.9%, 13%, 17%. It's growing very quickly in comparison to other things around it. And then also, if you take a look, JavaScript is up here as number 1, which is great because Node.js uses JavaScript syntax. It is JavaScript. We'll talk about that if you're not familiar with it. So, if you notice the trends down here, more people use JavaScript than any other programming language. PHP appears to be falling out of favor as Node and Angular emerge. That's kind of the main takeaway trend. And if we scroll down a bit more, we can take a look at the top tech on Stack Overflow. You can see JavaScript up nice and high still. If we look at trending stuff, you'll basically see that it's all JavaScript, well, almost all JavaScript related. React is JavaScript. We've got Node. Nowhere on here is PHP. Now, I don't want to say that you only pick something based off of if it's trendy or not. That's not the point here. The point is more that I picked Node because it is something that will prepare you for the future. And if you want to learn PHP, there are so many options out there. And I didn't want to just make another version of a course that could have been made a couple years ago. I wanted to make the most up-to-date current course. So basically, it's a decision that I made. There is not one answer. You could still make a great PHP and MySQL course today. I'll probably end up adding a little PHP section, but it's not going to be the focus of the course. And minor thing, but it is interesting if you look at top paying jobs, or if you scroll down and look at what a Node developer on average is around $85,000. You look at PHP, $10,000 difference. So not that that's why I chose to do that, but it is interesting to see. And then finally, if we look at the correlated technologies, you can see PHP and SQL. There's a tight correlation there, right? But there's also JavaScript and SQL, which is what we're going to be focusing on, and that's becoming very, very popular, a great combination. So that's so that's sort of some of the data behind why I picked that, why I came to this decision, if you're curious about it. One other thing, there's a good Quora post about why PHP is losing popularity, why people are trying to do Node and stuff and Ruby, and why people are down on PHP, which hopefully the takeaway is that that's not my intention, is that I am not trying to make PHP seem bad. I am just trying to show you another option. All right, so thankfully this was an optional video. You didn't have to sit through this, and not that you have to sit through any video, but well, we're done with it now. Thanks for sitting through that if you chose to. Next up, we're going to introduce our very exciting, fun project. All right, so we're back. If you watched that optional, kind of boring video, we're now moving on to an exciting and non-optional video, which is all about the project we're going to make. So we're going to build a simple web app to start using Node and MySQL together. So what is this app? Well, it's called Join Us, and it's a a startup mailing list application. So you've probably seen this before. When there's a new company that's launched, maybe you haven't, but if there's a new company that's launched, they're not quite ready yet, but they want to get their name out there. They want to start getting interested parties registered or collecting their information so they can send updates, or so they can invite them once the application is launched. So that's what we're going to build. Basically a way of collecting people's emails, and it looks like this. Now, I'm not, a great designer in any way. That's not the focus of this course. Hopefully you think it looks okay enough, but really what I just want to go over are the different features. Now, it's not very feature rich. The point is to make something simple, but to show you how we're connecting with MySQL through Node, and how this application kind of showcases both selecting information and inserting information. So the first thing you'll see, there's a photo here, and we don't have to worry about copyright or licensing issues. I actually took this photo. It's a bit of a brag, I guess. Sorry. But back to the content here. We've got join us in big letters, and then we've got enter your email to join, and then a number here, and this number changes. So 518 is basically the count of all the users currently in our database. So when I made kind of this, what will I call this? The alpha version that I made screenshots of that I made before, I have to make the app before I teach it. So when I made this version, I had 518 users in the waitlist, in the database. We are 100% not a cult. Then the other thing is this enter your email, join now button, which you enter an email, it's going to take that email address and insert it into our database. So there's kind of two things we're doing, right? Selecting, we're going to count how many users are in the database. We don't need all the information. We don't need 518 email addresses. We just want to know how many. And then we want to be able to insert something from a form. When you click this button, it's going to go send the data to our Node server. Then the Node server is going to send it over to the MySQL database, wait to see if it worked or not. And then it will do something, we'll decide what it does. Does it take you to a new page? Does it just refresh the page? Does it show you a message that says you're signed up? Whatever it does. But the key really is about adding information to our database and getting information out. Okay, so that's how it basically works. Let me show it to you. Here I am. I've got join us. Let's create a new user here. Let's call it, how about bluethecat@gmail.com. We click join now. And you can see it takes us back, which we can decide what to do. If we want to change that, I'll show you how. But now it says we've got 519 on our wait list. And I can refresh, I can stop the server, which we'll see how to do in a little bit. This will be 519. This isn't hard coded in. This is coming straight from the database. Okay, so that's it. Now let's talk about how it works. What's the workflow like? When I go on my computer, like I just did, and I refresh the page, or I enter that address, and I hit enter, a request is sent to our Node.js server, which we'll see how to set up in a little bit. And the Node.js server has code that says, oh, okay, this client is asking for our homepage. Well, on the homepage, we're supposed to have a number here of the total number of users in our database. So let's ask, hello, MySQL database, can you tell me how many users are in the database? And hopefully you're aware that would be a count. So we do a select count star from users. That will come back and we'll say, ideally, 518 or whatever it is, 1,000 users. And then my server, the code there, takes that number and it plugs it in, puts it right here, and it sends us the page. Sends it back, and I see the page. Same thing, roughly the same thing happens when I enter my email and I click join now. I'm sending my information, my email, to the Node.js server with a message basically saying, I want to add this. I'm signing up. So then my server says, oh, this time this person is trying to sign up. They're not just asking for the homepage, they're trying to sign up. Okay, MySQL, I'd like to insert this user with this email address. Then MySQL will say that worked, or, oh, we actually already have a user with that email, so we can't do that. Or something else, maybe there's an error. That will be sent back. Node.js figures out what to do. Do I send an error message, or do I send a congratulations success message? Do I just take them back to the home page and refresh it? That's, the decisions that are made here. So that's the basics. But then the next thing is, where do we start? There's a lot of pieces here, right? We have to talk about Node.js, installing that. We have to talk about how it communicates with MySQL. We have to talk about creating web apps in HTML and CSS and JavaScript, all of this stuff. There's a lot of moving pieces. So where do we start? Well, we're starting with this handy dandy green box. We'll draw your attention to the right side of the screen, which tells you we're starting basically with the relationship between Node.js and MySQL. How do we talk from JavaScript to MySQL? So we're going to start with basic things like I want to select the current date from JavaScript, or I want to insert a single user into MySQL. So no web app. This whole left side of the screen will be gone for the first part. But then once we have this relationship established, we figured out how to insert a user. We figured out how to select all users or select the count. Then we will then kind of expand into the web application and add in the logic for creating a web app. So that's our game plan. We're starting with this side. So the very last thing to discuss is what our table will look like. So for this web app, very simple, right? All that we need to store for every user, and we'll just call it users. We could call it, emails or interested people or whatever, wait listers, but we'll go with users. And all we need to store is their email address, right? That's the key thing, and that's all they're entering. But it's also would be really useful to store a created at. So we'd have a timestamps for when that user was created so that we could do things like figure out when most of our users signed up, or what day of the week most users are signing up, or just count how many users we've had, this year compared to last year. So it's really nice to have created at. It's very simple as well. So those are the two fields we'll be working with, the two columns, and that's it, nice and simple. And then the other thing to discuss is our game plan from here on out. And our first goal, we talked about how we're only working with this side of the table or of this diagram. What we're going to work up to is using Node.js to randomly generate and insert over 500 users into our database. So I had like 518 users in there. They all had unique emails. I did not code those by hand. I used a tool that generates them for me. And then I'm going to take that and insert them into our database. So basically shows you the power of using a language like Node, that we can very, very quickly generate data and not have to waste time getting 500 test users in there. So that's the first goal we're working up towards in this section. All right, so moving right along here, we've established we're working with Node.js. Now we need to set up our environment so that we can do that. Fortunately, Cloud9 makes it really, really easy. It's basically a single button press, maybe two, and we have a Node environment ready to go. One thing before I do that, I do want to talk a bit about what the course is and isn't. Yes, I know it seems like I'm leaving that a bit late, but really what I'm talking about is that this is not a Node.js course. This is not going to be comprehensive. This is not going to teach you, a tenth of what you would want to know about Node.js if you wanted to be a Node.js developer. This is not an HTML or CSS or, Bootstrap or whatever tools we use. It's not a course on those tools. They are helping us. They're serving a purpose, which is to make an app with MySQL. It's a MySQL course. And we're basically using those tools as needed. So I'll try and strike a balance as we go on here. I'm not going to just speed past and ignore, explaining what certain things are, and just assume or assume that you don't care what, a certain line of JavaScript does or what a line of CSS does. But I'm also not going to take the time to explain every single line, to have, challenging CSS and HTML and Node.js exercises and so on. We're still going to have exercises around MySQL. So I just want to throw that out there just to set your expectations. And also, if there is a chance that you want a full course on those technologies, I have a 45 plus hour course on those technologies that you can check out. But you don't need that course to get through this. That's kind of the point. I'm going to show you enough, but I'm not going to spend 10 hours talking about Node. Okay, so with that said, let's hop over to Cloud9. And we're going to go to our main kind of dashboard. So not inside of the editor, not inside the Cloud9 environment, but we're going to go to our dashboard. And you can get there by just going to c9.io, signing in if you're not signed in, and it will take you here. Now, I have a bunch more than you probably have, unless you've been playing around. But all that you need to do is click on Create a New Workspace. And we'll call it whatever you want. I'll call this Node and MySQL. You can call it whatever you'd like. And then what we're going to do is down here, this is the important part, click Node. So we could get away with any of these. We could install Node.js ourselves. It's not actually terribly difficult. If you want to install it yourself on your own machine, there are great instructions online. Just go to the Node.js website. You basically just download a package. But we're going to be doing this using Cloud9. It's going to make it very easy for all of us to be on the same page. And that's it. Node.js, give it a name. Create it. It will take a little bit. I'll use the magic of editing to fast forward through this. And we're back. And this is what we see. So there's a couple things. One, we have a new environment here. None of our old files are here. None of our old databases, the books or the whatever we've been working with, customers' orders, that's not here. It's not gone. You would just have to go back to that environment. But more importantly, we have Node installed here. And we want to test that out to make sure. So what Cloud9 does is they actually give you kind of a starter app that we'll just delete. But before we do that, we'll just make sure it works. So they have instructions if you want to try it. All that we have to do is type node server.js. And actually, before I do that, ignore my ice maker. It's very noisy. If we just do ls, all right, we see we have server.js. Let's just open it. There's code in here that we didn't write. We're going to get rid of all of it. And there's my fridge now. Oh boy, so noisy. Hopefully they're done now. So we've got all this code that we didn't write. This is Node. This is JavaScript. We'll be getting to stuff like this. We're not going to make a chat app. That's what this is. But we'll be working on something similar. So now if we do node server.js and I hit enter, we should get something like this. Chat server listening at 0.0 blah, 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 8080. Okay, so that's the first thing. If you get that, that means that Node is working. If you get something like error, command not found, Node, that means that Node is not installed. And I highly doubt you would ever get that if you had created a new workspace and done this kind of the way that you're supposed to. But if you're just working on your computer or you're working in a different Cloud9 workspace that isn't set up with Node and you try and type Node, then you'll get an error. And then the next thing to discuss is, okay, we have our app running. We started a server. Now, how do we interact with the app? Which is something we'll be doing once we create our web app. We'll start it up, but we'll need to view it. You can actually click on this preview button and just go to preview running application. And here it is. Or you could also just copy this URL. I like to keep it in a separate tab and just paste that in. And we have a chat app now. If we wanted to, this isn't part of the course. This is not important that you understand, but we can send it. And I could do this in 2 windows. Now we have, Colt and anonymous, so I can decide on a name. It's my cat. And my cat says, meow, go away. Send that. Anyways, you can see we have a chat app working. Here's a simple web app that we didn't create, but is running with Node. And that's important. Okay, so we can stop it using Control-C, just like we could stop the MySQL CLI. And that's where I'm going to end this video for now. Next, we're going to do sort of a 5-minute crash course on Node. But for now, what we talked about was creating the Node environment. We have this environment, and then we talked about how if we have a server running, we can preview it by clicking on preview, or we can open it in a separate URL or in a separate tab or window. One thing to note, I stopped it. So if I try and refresh the page now, I get an error. There's no application running. Okay, so it's time for a 5-minute crash course of Node and JavaScript. Obviously, that's not enough time to even scratch the surface, but I'm just going to show you the basics of what you need to know for us to continue on with the course. Okay, so back over in Cloud9, we will delete everything, get rid of it. So you can do that either if you want to use a command line, you could use rm and rm-rf, or just highlight what you need to delete, right click, and where is that? Delete. and then we'll say yes to all. We want to remove all of it. And we're home free now. We can get rid of some of this stuff. Perfect. Make some space. I'll bring this up a bit. And now all that we're going to do is make our first JavaScript file. We can call it whatever we want. You can either use touch app.js, or you don't have to call it app.js, or you can right click over here and click on new file. I'll do that one. And I will call this, well, I'll do app.js. It's a standard name. Okay. And I won't recreate it down here. Now we'll open it up, double click, and we'll add some JavaScript in here. So what I want to show you is this basic workflow with Node that we kind of saw already. We type some code in a file, we save it, and then we execute the file with the command node space and then the name of the file. So it's very similar, at least in principle, to what we did with the SQL files, where we would save a SQL file ending in .sql, put something in there, a query, then we would execute it using source and then some file name .sql. Same idea. So I'm going to show you some very simple code. There's something called, and again, if you know this stuff, feel free to skip it. Something called console.log, kind of the simplest possible command you can do in MySQL. It will just print something out. So we can do our basic hello, whoops, we don't need caps. Hello world. And we'll put a semicolon there, which should seem familiar from MySQL at least. And let's start with this, our first application, very basic. Then all we need to do to execute it is come down here and type node and the name of the file, which we called app.js. And it runs. Silly, but it works. Okay, so that doesn't seem useful, of course, but it's something, right? And to see kind of why a programming language would be useful, let's at least do this 500 times. Maybe that's not useful, but we can at least see how it's helpful at doing something that we can't do on our own. So we can create a simple loop. We'll do less than 500. Now, in my other courses, this is like an entire video, 5 or 10 minutes with exercises, but I'm not going to spend time on that. What this here does is it says whatever's inside of here, repeat 500 times. Basically, this is a counter saying, okay, we're starting at 0. And every time through the loop, we're going to add 1 to I, which is what this does here. So we go 0, next time around 1, 2, 3, keep going while it's less than 500. As soon as it hits 500, we're done. Okay, so if I just put that in there, whatever is in these brackets here will happen 500 times. Let's do it now. One thing I could add that I probably should is this var keyword. It's just, don't worry about it, but it's important to have it there. Now if I run it and I scroll up, you can see we get hundreds of hello worlds. Well, 500. So imagine, you might be wondering, why do you care? Well, imagine instead of console.log, what if we had insert a new user into the database? That would be a fantastic way to quickly seed a database with a bunch of data. Remember how we had to do this obnoxious copy and paste? So I would give you a file, you would copy and paste, like for the movies data and reviews, there was these big files, you had to copy and paste it in. It's an awful way of getting sample data. Well, we can use JavaScript to create data for us. So just a couple other things that I'll show you. We can do math and basic things like 5 plus 5, and I won't do this 500 times. We can comment things out, selecting them and doing command /, so that won't run anymore. So now I'm only running 5 plus 5. You can see we get 10. One other thing to address is what is Node, if you're not familiar with it? And that's actually a pretty common question. There's a bit of confusion about Node.js, which is what it's called, and regular JavaScript, and what the difference is. Basically, JavaScript is a programming language. It was created first. It's been around for a while, and it's existed as a language that you can use on the client side. So what that means is that back on this diagram, there's a line right here. Not right now, but imagine a line. This is the client side. So I could write JavaScript code that did things over on someone's, like on my computer. You could write code that would animate something or make a game or just add some pretty effects. That's not to say that it's not powerful, but traditionally it was used kind of to decorate pages, if you will. and it had nothing to do with databases. It had nothing to do with servers. You would use another language over here, like PHP, and you would use JavaScript on the client side or the front end. But then Node came around about 5 years ago now, and what it is an implementation of JavaScript written so that you can use it on the back end, so that you can do things like this. You can create a server with JavaScript instead of having to do it with Ruby or PHP. And it can talk to a database like any other server-side language. So to summarize that, Node is JavaScript. It uses basically the exact same syntax, but you can use it on the back end, which is what we'll be doing in this course. So I know that was a very brief introduction to 2 lines of Node and of JavaScript, but we're now moving on to more important things that are relevant to MySQL. And the first thing we'll do is talk about a package called Faker. So the first question you might have is, what is a package? And basically, Node comes with thousands and thousands of libraries. You might have heard them called, or packages or modules, code that other people have written that we can include inside of our application really simply. All I have to do is say install Faker, which is a package we're going to use. But we'll use another package later called Express, or we'll use one called MySQL. And all I have to say is install MySQL, install Faker. And there are thousands of them out there, like I said. And that's one of the biggest strengths of Node, is that it has a huge library of all these packages so that you don't have to do everything yourself. You can go and get some help by including somebody else's package. So the way we do it is through something called npm, Node Package Manager. And to install Faker, which, don't worry, I'll explain what Faker is. This is all we have to type into our terminal, npm install Faker. But before we go there, let me show you what Faker is. So Faker is a package that there's a bunch of different versions of it. I think the original one was for Ruby. I'm not positive, but there's Faker kind of implementations for other languages, including JavaScript. And what it does is it really helps us. It streamlines the process of generating fake data. So we're going to use it because we want to start off with a bunch of fake data in our database. I don't know, if you noticed, I had 519 users in my database. I did not enter those manually. And they're all unique. They have a different unique email address. I did not generate those myself. So we're going to use Faker to do that. So Faker's very simple. I can say things like faker.address.county, and it will give me a random county name, and it has hundreds of them. Or I could say let's say name.job descriptor, and it will give me a random job descriptor. So there's tons of things in here: phone numbers, random numbers, file names, colors, avatars, emails, usernames, domains, passwords, like so many things that we could pick from. Credit card, fake credit card numbers, account numbers. You get it, hopefully. So back in Cloud9 now, what I'm going to do is actually empty this file entirely, app.js. You can make a new file if you'd like. And now I'm going to install Faker so we can use it. So this video, I probably could have done a better job explaining this, is about 2 things. One, Faker, but on a higher level, packages in general and how you use them. So this is the workflow for using a package. We type npm install, the name of the package, and hit enter. And it will take a second. And that on its own installs the package. You'll notice I have a new folder here called Node Modules. Inside, there's all the Faker code, all this stuff. So all that is here now. I just had to type a single line. It's pretty awesome. Now in my app.js, I can't just start using it immediately. I can't just say faker.email or something. I first have to tell this file I want to use Faker. I have to include it or import it. And it's very easy. I'm just going to say var faker equals require Faker. So this right here, it's a variable. I can call this anything. I could say my Faker. I'm going to call it Faker standard. And this is the part that I can't change. This has to be Faker. So this is going to go find a package that I've installed in Node Modules with the name Faker, and then save it into this variable. So now whenever I use the word Faker, referring to this variable, I actually am referring to the package. So then we can do things with it. So we could do something like this, faker.internet.email. And that will generate things like this, or this, or this. Ori23, Simone Walsh, Aubrey_Daughtry, numbers, we've got Hotmail and Gmail and Yahoo. So this would be a pain if we were doing this ourselves to come up with 500 individual emails. And the other thing I'll show you is we're going to use it for dates. So I'll be able to say faker.date, and this is important, .past. So we don't want to have any future dates. Basically, we want to start with 500 users in our database who have signed up at some point in the past. So it will generate things like this. So we also don't want to have to do that ourselves. So let's start with faker.internet.email. And we need parentheses at the end, sort of like MySQL. It's a function, and we're telling it to execute. If I just do it on its own, and I run the file now, which is app.js, nothing happens. Well, that's a lie. It does happen. This runs, but we don't see the result. And that's because we need to print it. So we can do console.log like this. There we go. Now, if I run it again, I see, okay, we get a new email. Jared, Leila, Trevor, whatever. So we're getting these fake emails. We're going to use that along with, I'm going to copy this and do faker.date.past, which was the other thing I showed you. We're going to use those two to generate 500 users. So basically this is one user. So it's kind of fun to play around with Faker a bit. You could do, hacker abbreviation or finance currency symbol or Bitcoin address. Let's do address and then city. So we could do, I'll get rid of these two for now. Console.log faker.address.city. And if we save and run that, there we go, Robertoville. And if we tried it again, we get something different. New Alexandro Fort. So that's the basics of Faker. I will show you if you already know JavaScript, skip this section, but I just want to show a bit more, sort of the extended version of the crash course in Node, how we can string things together and make more complex logic. So let's say I wanted to generate a complete address. So I wanted, a number and the street and a city. Let's start with those three. So Faker has ways of doing that. We've got, what do we have? Street name and street address. So let's start with that. We've got faker.address.street address. Let's start there and run this again. Okay, so there we go. That's working. Then we've got the city, right? And then let's say we wanted to do a state as well, if we're working in the US. Perfect. So here's a complete address, right? Now every time, let's say I want 3 different addresses, I would have to copy these lines like that. Which is not the end of the world, right? We can copy lines. But there's a much better way of doing this. So what we could do instead is create what's known as a function. And I'll just call this generate address. Think of this as a way of reusing our code. And the syntax looks like this: function, a name, parentheses, and then brackets. And whatever we put in those brackets will be run every time I refer back to generate address. So on its own, if I just save this, nothing is going to happen. When I hit save, now I go down here to node, we don't get anything. What I have to do is now call this function just like this. Now it's saying, okay, is there something called generate address? Oh, yes, there is. All right, well, let's run the 3 lines inside of it. So if I ran this 3 times, now it's only 3 lines to do that. And we get 3 different addresses. Of course, we might want to, compile these together so that they're not on 3 separate lines. Maybe we want commas between them. We could really improve it. But the point is that that's basically how you define a function. And we'll be working with functions later on. But for now, that's all I'm going to show. Okay, so that's the basics of Faker, the basics of packages. We'll be installing other packages, as well as the basics of Node. Okay, so we saw the very basics of using Faker, really just a single line. you know it's a thing and that it's a package. Now, our game plan from here on out is to use Faker to generate our data for us, get 500 users in there. But Faker on its own won't do that. So we'll use this faker.internet.email. We want one of those, or we want 500 of those actually, and we'll use the date.past. And the reason we need to use date.past is that when a user is created, yes, in the real world, we want to store the current time when they actually signed up. But when we're inserting 500 fake users, we don't want them all to have the exact same time that they're joining, because then that throws off our data, right? Having 500 users who joined at the same exact instant. So we'd much rather spread them out so that we could try certain things with the data, play around with it. So we're going to generate dates using this. So then the next logical question is, okay, we know how to generate a single email and a single date. How do we do 500 of them? And more importantly, how the heck do we get them in a MySQL database? So warning, up here, red letters, this is not really code that will work. Well, it's not code that will work at all. But I just wanted to show you. We would want to do something like this, right? Insert into users, email, and created at, and the values, we want a faker.internet.email and faker.date.past. This is sort of a hybrid between MySQL and Node. Unfortunately, this doesn't work, but this is what we're going for, right? We want to do something like this. Insert 500 of these where we get a fake email and a fake date. The problem is, insert into users, this syntax only exists in MySQL, and Faker only exists in Node. So how do we bridge that connection? Oh, and we want to do that 500 times, right? The answer is that we use something called MySQL, and it's confusing because it's a Node package. Like Faker, it's another package called MySQL. What it does is it connects to MySQL, the actual database, and it talks to it. So every language, there are a couple different packages. PHP has a way of talking to MySQL. Ruby has a couple ways. They are kind of adapters. Think of it as a connector between the two, a tube or a pipeline. And there's a couple for Node, but the one we're using is the most popular. It's called MySQL, which personally I find kind of confusing. I wish it was called, MySQL Node or MySQL Connector or MySQL JS or something. And here's a couple diagrams of basically how it works. So we have Node on its own. This is where we've been working. And then we have MySQL on its own, our separate database. So this has our data stored in it. And the MySQL package will be able to say things like, hey, MySQL database, how many users are in there? Ask it to the database, and then the MySQL database will be able to say, well, looks like there are currently 518 users. Send that back to Node, and we can use it. Or it might be something like this. Hey there, MySQL database, how many users are in there? And MySQL might say, users, I have no idea what you're talking about. I don't have a users table in here. In which case, we would get that back to Node.js, and we'd be able to know that because of the package we're using, the MySQL package, is both asking the questions, right? It's querying the database, and it's handling the replies. So then in here, we can write logic that says, okay, if we don't get a response, if there's an error message, let's do one thing. Otherwise, do something else. Or a third scenario. Hey there, MySQL. Our adapter, our MySQL connector, might ask, how many users are in your database? And there's no database. We don't get a response. Well, we need to figure out how to handle that in Node. And fortunately, the MySQL package handles that. So it will, start by freaking out. Are you there? What's going on? A bunch of sad faces. But then it will figure it out. It will basically time out, and it will figure out there's no connection. There's no database there. And it will be able to handle that as well, which is something that could happen. Your database server could go down. Something could go wrong. So these are different scenarios. Mainly we're working with this one, right, where there's good communication and everything's working how it should. But the key thing is that the package, MySQL package, works in Node, talks to a database. So without further ado, let's see how that works. All right, so we're back here now, and our goal for this video, I'll just lay it out there, is to have communication established between a MySQL database and this file of JavaScript, of Node. It's not going to be crazy. We're just going to be basically running a very simple query like this. Select, we could do cur date, or we could do something even sillier like select 1 plus 4. But those are SQL queries that we could run in a MySQL database and get an answer. So we're going to run them from this file. And to do that, we need to first establish a connection. And even before that, we have a bigger thing to take care of, which is that we don't have MySQL set up in this Cloud9 instance. So if I'm back in the Cloud9 docs, you can see, remember when we ran this very, very early on, MySQL-CTL space start. And what it does is it starts MySQL in the current workspace that you're in. And if you read this note, it says the nice thing is that every workspace will run a separate database, so your projects will never interfere with each other. And that's really nice and useful. But what that means is none of our data from our previous workspace is available here. So all we need to do is just run this command. So we'll do that now. Here I am in Cloud9. I'm just going to run it. And all that we should see is that it installs MySQL. Everything's good. But something to take note of right now, the root user. So we need to remember this. And you'll see why in just a moment. So I'll just put a note down there. Don't make fun of my username, please. I regret it deeply. But it's here to stay. Learn with Colt. Yours will be something different, but we need that credential. Okay. So then the next thing, we now have a MySQL database. I'm going to open up a new terminal over here and just keep it open. And we're going to connect to the CLI. Remember how we do that? It's MySQL-CTL space CLI. Okay. And if we look at databases, we have nothing really. We have these kind of basic ones that we get from Cloud9. Let's create a new database. And we'll just call it join us. Already forgetting the semicolons. Okay, and then we'll use join us, just like that. So we have a database. And just to show you, if we run a command like this, select cur date, we get an answer. Or if we do select 1 plus 4 and I add a semicolon, we get an answer. So this is in MySQL. Hopefully that's no surprise that that works. Now the question is, how do we get this file, which is not SQL at all, it's JavaScript, how do I get it to talk to the MySQL server that's running and run some code in it? And there's a couple components to that answer. The first thing we have to do is install the package. So just like before, it's npm install, but instead of faker, we type mysql. It's the name of the package. We hit enter, and once it finishes, if you open up node modules, there's a new MySQL folder. So this is the code that connects. So on its own, it's not doing any connecting right now. It's a library, it's a tool set that we can utilize. But we have it on our machine now, we have it in Cloud9. So I'm going to come up here and require it, just like I did for faker. I'll type MySQL equals require MySQL, if I can type. That on its own doesn't do anything. Well, that's a lie, but it doesn't actually talk to our database in any way. There's a bit more we need to do, and it looks like this. So what we do is establish a connection with the database. So we require this first. We require MySQL, we save it to a variable. Then we run mysql.createConnection, which is a method that it comes with, and we have to tell it a host, which we'll go over later. We're leaving it as localhost. Then user, which is going to be whatever your username was. Mine was Learn with Colt. And then a database name. So we just made a new database. I think it was called Join Us. That's the one we want to work with. So if we copy this over, I'm going to get rid of our generate address for now. I need to fill this in. So some username for me is this right here, Learn with Colt. That is what MySQL is expecting. It says, please make note of these credentials. We want to keep track of that. Okay, so we put that in there. And then the database that we want to use was the one we just created, which was called join_us. Just like that. So if we try this right now, we try running this file, node app.js, nothing happens. And that's actually a good sign. that means that there wasn't a problem, but at the same time, we're not running any SQL code. The point was, by the end of this video, we want to do something like this. So then the next thing to do that looks like this. And there's a lot to take in here. I totally understand that. We're going to start by just copying this over, or you can type it as well. But this is how we run queries. Okay, so there's a lot. First thing I'll show you is we have a query. I'll just do select, let's do cur date. That's more accessible. So we write our SQL code in here, okay? So we could do whatever SQL we want. We don't have any tables yet in there, so we're not going to work with tables, but we could do something like this, like cur date. Then we just save that to a variable called q. Now this is the trickier part. So we've got connection this is our connection we created. So we're referencing it, connection.query. We're telling it to run the query queue. So I could have just taken this and put it directly here. It just makes it a little longer of a line to look at, but I'll do that to consolidate it and to show you that it works. Then we have this whole function, error, results, fields, kind of a mess here. There's a lot to look at. What this is saying is when this query is finished, so we're going to reach out to our database over here. We're going to try running select cur date. And if we just run it here, you can see it works. So if we try running it from this connection, whatever happens, when it's done, run all of this code here. It's called a callback. And again, I wish I could go into more detail, but basically this will run. And if there is an error, there will be something stored in error here. If we get results, it will be stored in results. And we'll talk about fields later. We're not going to use that now. So I have this if statement that just says if something happened, if there's an error, then just stop, throw error right there. Otherwise, and we can even get rid of all of this and just print out even more. Let's just get rid of everything and just print results so you can see what we get back, just like that. So there's still a lot going on, I realize. Unfortunately, it doesn't get simpler, but hopefully you can see the core idea. We have our query, and everything else here is just kind of the JavaScript wrapper around it to run this query. Connect to a database, run the query. So let's see what happens. Okay, so two things to notice. One, we get this row data packet thing back. We have cur date, colon, and then the answer for what cur date was, which is great. But then we also have this other thing. I don't know if you picked up on, my cursor has changed. I'm not in the regular terminal. I have to hit Control C to get out of there. And that's because a connection was opened, but it actually was never closed, it never ended. So it's not a problem, but basically that connection is persisting. So at the end, we can do a connection dot, it's either close or end. Let's try it again. There we go. And it ends now. And you can see we're done. Okay. So now let's talk about our results. First of all, we should pat ourselves on the back for getting this far. We now are running simple queries, yes, but we're running queries here in this node file. This sets the groundwork for everything else we need to do. So imagine that instead of a single select cur date, what if this was insert 500 users and we're passing that in and we're running it from node talking to our database, which hopefully you think is cool. Let's try changing this to something like select 1 plus 5. Saving it. And you can see we're now getting row data packet 1 plus 5 colon is 6. So this, what we're getting back, this syntax is kind of wonky. I totally get that. The way we can get around it, if we just want the answer, we can start by adding in 0, which is basically, if you're familiar with an array, it's going to give us the first item. So if we try this again, now we're working with this row data packet in particular. And to make this easier to access, I can just go in here and add an as. So if I do as answer, for example, select 1 plus 5 as answer, I mean, if we run it over here, this is what we get, right? Well, this is not JavaScript. So the whole job of this MySQL library is to, or the package, is to figure out how to take this and turn it into something we can use. So if I do as answer, now I try it again. you'll see that it's stored now under the keyword answer. So I can access it just like that. Perfect. So last thing that I'll show you, let's do select, and I'm going to do this one in a separate line, or as a separate variable. I'll call it var q. And instead of just selecting 1 plus 6 or 1 plus 5, let's do select cur time as time, comma, cur date as date, then finally now as now. And I do need that right there too. Okay, so if we do that, and I put Q here, I'm basically just saving myself from having to make a gigantic line. So by referencing Q, it's referencing this query, which is very useful. It's going to run it. And rather than doing all this, let's just look at results like that. See what we get. Okay, now if you look at our results, we can do results 0, which will just get us basically the same thing, but we don't have this array around it anymore. More importantly, we now have 3 items coming back, which should make sense, right? If we went and took this over to MySQL, don't forget the semicolon this time, we get 3 results: time, date, and now. So then the question is, okay, let's print them out all separately. So we'll have 3 prints, but we need to access them individually. So we'll do time first, and then date dot now. So by putting in this alias, the as, when it comes back from MySQL, so imagine that diagram. We're sending it over. We're saying, hey, please send me, let's say, cur time as time. And it does that. Okay, here's cur time as time. I'm sending it back to you, JavaScript. This JavaScript library takes it, sticks it in the results under the name time. Only because we gave it that alias. So whatever I change this to, I would need to access it under that name. Anyways, now if we do it, there we go. I'm getting the 3 different things that we asked for. Okay, so that's the extent that we're going to work with it here. Next up, we're going to create our table, and we're going to see how we start inserting and selecting data from this file. So rather than just selecting cur time, we're going to actually do something with the database, something that we couldn't do without MySQL. Okay, so in the last video, we got our node file, JavaScript, communicating with our MySQL database. Albeit very, very simple communication. We're not actually interacting with tables, but this is SQL code that we're running. So the next step, of course, is getting it to interact with tables. So we're going to, in this video, we're going to create our table. We're going to define our schema, create our table in MySQL separate from JavaScript, and then we're going to try and query it from here. So basically, we're going to go into MySQL, create our table, let's add 2 or 3 users, and then we're going to see if we can fetch them from Node. But before we get there, one thing I want to address very briefly is when we're looking at this code, this connection.query, function error, results, fields, or this code up here, var connection equals blah, 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 you might be wondering, how did you know what code to type? Where did I find this? It's not in the MySQL documentation. This is not an official MySQL sanctioned library. Basically, the way that it works is that random developers, teams of developers, solo developers, go and create these libraries that connect MySQL to other languages. Some of them are more supported than others. Like I said, some of them are just one person, but they usually have their own documentation. So the documentation for this is on GitHub. It's github.com/mysqljs/mysql. There goes my fridge again. Oh, very active today. But if we scroll down, you can see, well, there's a lot of stuff to take a look at, but it basically talks about installing it, talks about setting up your connection. It talks then, if you keep going down, about once you've established a connection, what can you do? Well, here's a very simple query. We saw something very similar, although this is just selecting one. We did something a little more complicated, but if we keep going, eventually you'll see we get to things about querying, which is where we're going just in a little bit. But basically, I want to show you there is a source of documentation. So here we talk about some queries, how it works. We'll come back to this in a bit, but I'm not just pulling this stuff from nowhere. And I certainly don't have it memorized. I'm not just, I don't just know how it works. I'd say the approach is more, okay, I know what I need to build. I'm going to be building it with Ruby. Now let me find the Ruby MySQL driver, or a gem, which is what they're called instead of packages in Ruby. Let me find a MySQL gem. Is there a connector? And then you find it. And then you look through the documentation and you figure out how it works. Okay, how do I connect first? That's the first thing you need to do. And there's not one syntax. It varies from language to language. Somebody made a decision. So if we go back to our slides here, somebody made the decision to call this method query, which, it makes sense to call it query, but it could have also been called make query or perform query. Or when we're creating the connection, mysql.create connection, I don't know, someone could have called this could be database name instead of database, but somebody's making those calls. And I'm not disagreeing with the way this is named in any way, but I'm saying you have to play by the rules of whoever defined this. Just like when we're working with MySQL, we have to use the MySQL syntax. There's a specific syntax we have to learn. Same thing for using these libraries. So it's not something that comes standard with JavaScript or with Node. It's something we had to plug in ourselves. And that means we need to go do the work to figure out how to use it. Okay, so next up, we're going to create our schema. And it's pretty simple. All that we need are 2 fields. So we'll run create table users. We'll do email, and a pretty standard length is 255. So not that an email is that long, but for fields in general, text fields, people will do varchar 255. And we'll make it a primary key. Why do we want to do that? Basically, we don't want someone to be able to sign up twice with the same email address. Also, it gives us a couple more options for exercises, so it's a good thing to do, and it's good practice. This is probably the first time we've seen primary key without auto increment. Then we've also got created at, and that's going to be a timestamp. It could be a date time, but remember back to that video I did about the difference. Timestamp is smaller, it takes up less space in memory, and it works just as well, except for really far away dates in the past and in the future. 1970 up until 2038, I think it is the current range. We're not going to worry about that because we're dealing with current dates. We're creating a mailing list app or a wait list app. People are signing up now. So we don't have, nobody's entering a date from 1650 or something. Then we're setting the default value to be now, so that when someone signs up, it will automatically be filled in as the current time. But don't forget, when we're working with Faker, we are going to insert like 500 users into this table, and we are going to provide a created at time so that we don't get 500 users with the exact same time. So we want this default value to be there, but we'll also be able to override it manually if we want to. Okay, so let's hop over to Cloud9, and the first thing I'm going to do, close this down, is just make a new file. I'm just going to call it schema.sql. And the only reason I'm doing that is just to have a record of this. You could just open up MySQL and start typing create table, but I'm going to do it in here, create table users. Okay, so we wanted email, and then we wanted created at. And email is varchar 255 primary key, and created at is timestamp. It would work just fine if you left it as a date time. And we want default to be now, or we could also say current timestamp. Okay, just like that. And we'll save. We'll hop down to our terminal down here. I'm in the MySQL CLI, and I'm just going to select database right now and see what we're working with. Good, we're in the join us database. So we made a new empty database. If we look at, show tables, there's nothing here. That's good. So we're going to create this. You can either copy it and paste it in, or you can run the file, which I'll do just because it's been a while. Source schema.sql. Okay, now let's see if it worked. Show tables this time. Now we have a users table, and we can describe it. Perfect. So that's all in there, which is great. Now what we want to do is insert, let's say just 2 users, just so that we have something. So we'll do an insert into users. This will be one of the last times we're actually inserting stuff manually, rather than using our code to do it for us and inserting 500 at a time. So all we're going to do is insert email, and we'll leave off created at for now. We'll just have it be the default. So that means we'll have, what do we want to do? Let's do Katie34 at yahoo.com. And then we'll add in another one, which will be, let's do Tunde at gmail.com. Sure. Just like that. So just 2 users. I'm not going to source this again unless I commented this out. Otherwise, it would try and create users again. Just copy this. Do we have any syntax issues? We'll see. Okay, it looks good. We can do a quick select star from users. There we go. Okay, so we have data in here. That's all we need to start. Now, our goal is to come over to this file, and rather than doing these silly select cur time and cur date now, we're going to try and select from the users table. We want to make sure that not only are we connecting to the database, which we've already established, but we want to see if we are able to connect with that table and query it. And the syntax is actually the same. So I have a slide on it, but if you notice, we're just doing connection.query, and then we just have a query here that we can replace with whatever we want. So our query is what? How do we select everything from users? Well, we just did it. Select star from users. So we'll save that. And, again, you could just copy it and paste that right there. I'm going to get rid of all of this because we're not working with time, date, and now anymore. All I'm going to do is say, if there's an error, throw the error. And then we'll do console.log results, just like that. So I'm going to get rid of everything else here, just these. So this is just set up. We're not even using Faker. Can get rid of that. All that I'm doing, connecting to the database. Then I have a queue, which is just storing our simple select star from users. Then I'm doing connection.query. So take this connection we set up, run this query, which the first argument is select star from users. The second argument is everything. Basically, it's a function that will be called when our query finishes. So when it either comes back saying, great, it worked, or it comes back saying, hey, your database isn't running, or I can't find that table, whatever it is. If there's an error, throw the error. If there is no error, this is empty. There will be nothing there. And console.log results. So we need to go over to the correct terminal and run it. Make sure we save. I have a circle up there. So save nodeapp.js. Okay, take a look at that. We've got 2 results. Each one is a row data packet with an email and a created at. Email and created at. So that's looking good. We are getting our data back. And if we wanted to only take a look at Tunde and his information, we can drill down and just access results 1. They're indexed at 0. It's an array, JavaScript. So this is the 0th result, and this is the first. Save, run it again. You can see we now are only dealing with Tunde. And if we only wanted to print out, let's say, his email, you can just do .email. And there we go, Tunde at gmail.com. Okay, so that's the first and most basic thing that we can do as far as selecting. So now when we're talking about this join us application that we're making, we're never actually selecting all the user information. We're going to have 500 or 1,000 users, ideally more. We're not selecting all of them. What we're trying to display to the user is just how many there are. We're trying to display how many users there are. And that is just a matter of counting. Now, we could do it a really kind of bad way. I was almost going to curse there. A really bad way, which would be basically select all the users and then just run results.length, which will tell us how many results there are, which gives us 2. So that's a really bad way of doing it, because if we have 10,000 items in our database, we're going to go select all of them, bring all of them back here just so that we can do .length on it. I don't think that's a good way of doing it. So rather than doing that, what we can do instead is just do count. Select count star from users, just like we've done before. Now if we do it, you can see we get count is 2. And a nice, remember, we can add in an as, so we'll call it as, let's call it total this time. And it needs to go here after the field before the from. And now if we run it again, you can see it's stored under total. And if we wanted to get that, it's just a matter of results 0 dot total. And now we get 2. So this is a much better way because we're asking MySQL to count and just give us the count back. We don't actually need every row. So instead of 10,000 results back, just give us this count and then we can work with that. So this is what we'll be doing. We will have a query like this when a user goes to the home page of our application. Bear with me while I scroll back. Should probably just edit this.
Speed it up. Okay.
But when a user goes to this page, this number is the results of our node, or Node.js, running that connection.query select count star from users. And whatever number comes back, we are sticking in the markup in the HTML. Okay, so then that brings us to inserting data. What if I wanted to instead insert a new user? So I'm going to copy this. Well, first I'm going to comment that out so we have a record of it. And I'll make a note. Selecting data. Okay. Now we're going to try inserting data. And you would think that all we needed to do is something like insert into users, specify, let's say, email, values, and then all we want is, we'll do 1 here. And we have to pay attention to quotes because we're working inside of a string. So we need to use double quotes here. And let's say we just make up an email. We'll call it Wyatt the dog at gmail.com. It's one of my family dogs. So if we do that and we insert that, so if we kept everything else the same, let's just console.log results, just like that. And if there's an error, throw the error. So this is regular SQL, right? If we ran this, and we could verify it, of course. If we ran this right now, it works. So now let's change this a little bit so that we don't end up with 2 of them. But everything else is valid. So let's do that. Run it, connection.query, this query, function blah, 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 blah. If there's an error, let us know. Otherwise, print the results. Let's see what happens. Okay, so look at what we get back. First of all, it says OK packet. We get field count 0, affected rows is 1. There's no message. Everything looks okay. If we went over here and did a select star from users, you'd see that Rusty the dog is now in here. So all of that is looking good. And that's correct. This is working how it should work, which is good. But this is not something that really is helpful to us. Inserting one item at a time that we're hard coding in, where I'm saying Rusty the dog, that's just not great. Like, this is SQL we're writing. We could, if we wanted to insert Rusty the dog exactly, we could just copy it and do what we did and paste it here. What we want is to be able to do dynamic data. So I want to be able to say, which we don't have Faker set up, but I want to be able to say faker.internet.email, which is going to give me a random email address. And I can't just stick that in here. That's not going to work because it's going to just try and insert an email address called faker.internet.email. So there's another syntax we use. In truth, you'll probably never use this for inserting, where you're actually hard coding in the data you're trying to insert. What you'll actually do looks something like this. So we have a slightly different syntax. First thing you'll notice is that I'm creating a variable that is storing the person or the user we're inserting. And it's a JavaScript object where I have a key, email, and then a value, jenny467@gmail.com. We'll come back to that. Then our connection.query looks the same, but our query is different. We're doing insert into users and then this weird set question mark thing. We've never seen that. Is that valid SQL? Is this something else? And then also we have a new argument. We're passing person in as well. And then our regular function with error and result. So what I'm going to do is copy this over. I'm going to comment this one out as well. And I'll call this inserting data take 2 and paste this. Okay, so a couple things to go over. 1, does it work? We'll try that in just a moment. And 2, how does it work? So we've got this insert into users. That's the same, right? That's what we had up here, insert into users. But then we had to specify exactly what we're inserting. So we'd say, email, and if we had 10 columns, we'd have to say email, comma, X, comma, Y, comma, whatever they are, right? As we're used to. But there's another way. What we can do instead is make a separate entity in JavaScript, an object, where I could come in here and do something like email is Jenny. We don't have name, but we could have, if we had it in our database, we could have name is Jenny. We could have 20 different things. And to insert it all correctly, all I have to do is connection.query, insert into users, and I add set question mark, and then the second argument is this object. And what will happen is this MySQL fancy library, this package, will basically take this object and it will figure out, okay, there's something called email. Well, then I'm going to turn this query into insert into users email values Jenny 467 at gmail.com. We have a quote issue again, so I'll make those double quotes. Okay, so it will turn it into this. But if I had something like email, and let me indent this a little bit better. Let's say we had email, comma, and let's say birthday is 2001, comma, 11, comma, or /11. We'd actually need dashes for MySQL, but let's say we have that. Well, by just passing it in here, I never have to mention birthday. It will know when inserting it to then have birthday equal to this. So I won't go and type the whole thing, but the point is that it can dynamically do that for us. And that doesn't seem that helpful when we're inserting one thing like this. It's the same problem or it wasn't a problem, but the same thing we ran up into here. Like if you're just inserting this one hard-coded email, why does it matter? And the answer is down here. Well, it matters because now we don't have to hard-code it. What we can do is change this string because we're no longer part of up here. Whatever we're typing is inside this text. But down here, it's not. It's separate. So we can replace this with something dynamic, like using Faker. But let's start by just making sure that Jenny works, just like that. Jenny467 at gmail.com. Let's save. And let's see what happens now. Insert into users set person is this. Okay. And it looks like we got an error this time. And it tells us, oh, okay, well, this is a silly one. This is my fault with the code, but it's something it's good to talk about. If you look at what the error is, it's telling me error is not defined. So it's saying this thing error is not defined. And actually, I was ignoring these, but I'm sure Cloud9 is trying to tell me. Yes, it is. It says error is not defined. And that's because up here I called it ERR. You can call it whatever you want. So I could call this mistake in all caps. It's a bad idea. It would be a mistake to use all caps, but as long as they match. So I'll go with ERR though. That's a standard thing, just like that. Okay, now we get a different error. This time, oh my goodness, it's the same one. Jeez. Now we get a different error. This time it's saying duplicate entry. Great, this is good to know. Now it's telling us we already have someone named Jenny467 at gmail.com. And the reason we're getting this error is that we already have a Jenny in there. So this is interesting, and this is why I added that primary key. So we just like 1 second ago inserted Jenny467 at Gmail, and we hit this problem with the error coming back where we had a syntax error, but it was still inserted. Remember, this code only runs when the insert or the query is done. So we inserted Jenny467, then I screwed up our code, and so it broke right here. But Jenny was already added. So now we just added another Jenny, or we tried to, and this time it came back saying there's a problem. And if we look at the error that it threw, it says duplicate entry for key primary. So you can see now how JavaScript is talking. This is the kind of, remember those arrows, I won't go back to the slides, the two-way arrows, where we tentatively tried to insert from Node, hey, can we insert Jenny467? Waited until it went to the database. The database said, let me think. No, sorry, we already have Jenny467 and there's a primary key constraint. Don't you remember? You made the schema. Well, that's a problem. I'm going to have to refuse your request and send you back an error, which then is passed into this. and this part runs. If error, throw the error. Okay, cool. So that's good to know it's working. So rather than doing Jenny467, let's change this to something more interesting anyways. Let's go back to using faker. So we need to require faker again. Require faker. And all we'll do is insert someone with a new email. So it's just faker.internet.email. Like that. So what this will do is, instead of having us hard coded it, every time we run this file, it will insert a new email that it just generates. So let's try it, see what happens. Okay, it looks good. Something happened. Now you can see we got velma94@gmail.com. And let's do, how would we only identify the last one that was most recently added? Quick review. Well, we could do an order by created at. If we did it that way, you can see the last one is Velma. We're going in the wrong order, so we can do descending, and we could throw in limit 1. Now we get the most recent one. So if we go back to bash, try running it again and again, we've got Sanford Gaylord 61. And actually, if I change limit to 2, because we just inserted 2, we also have travis60@gmail.com. Sweet. So I'll end the video here, but we saw now how we can insert things dynamically and why this syntax is preferable to this one up here, where we're hard coding it as a string, as text. This works, but it's limited, right? We can only insert whatever we type. This allows us to be dynamic. And shortly, in our web application, we won't have faker.internet.email. We'll have, this is pseudocode, whatever the user entered into the form. So when we have that form, the user enters their email, whatever they type in there, we're going to stick here. And we don't know it, right? We can't type it out exactly. We don't know what the email is itself, but we can save it in a variable. Okay, so we'll go back to faker.internet.email, and we'll leave it there for now. Okay, so let's refresh what our master plan was here. The whole point of using faker was eventually we want to be able to insert 500 of these, where we have an email that's randomized, and we also want to have a date, a created at date that is randomized. So let's focus on that part. We saw, just to refresh your memory, that we can do things like this. I'm going to comment all of this out and to just run one line at the bottom, which is console.log faker.date.past. And that just gives us date in the past. I think it's within a year and maybe 2. And let's see what I'm screwing up here. We've got faker.date.past, console.log, and we'll go over to the correct terminal here, and we'll run node app.js. Okay, now we're getting a date. Now you may have noticed a problem here. This date syntax, which I'll put here just so we can take a look, it's not valid JavaScript as it is, it's complaining, but this is not going to jive well with our database. Remember that our database, MySQL, is expecting something like this, where we have the year, I'll just do it as year, dash, month, dash, day, space, minute, or what do we have? Hour, minute, second. So sort of, the time part looks okay. Then we got all this stuff that we don't want. The year though, the month, the day of the week, we don't want the month spelled out. We just want the day. So this is a problem. So to prove that it's problematic, let's try something. Let's try taking, let's say this date right here, Monday, April 24th, 2017, copy it over, and let's insert it manually into MySQL and see what happens. So I'll do an insert into users. We have email and created at values, and we'll just pick a random email. Let's do dusty@gmail.com, comma, and then we'll pass in this giant JavaScript date, or the JavaScript style date string. What do you think will happen when we insert this? So I'm just going to paste it in and hit enter. All right, 1 row affected, 1 warning. Well, let's see what happened. Let's do a select star from users. Well, actually, let's do select star from users where email equals dusty@gmail.com. And look at that. Created at is all screwed up. It set it to 00000. It's a problem. That's not going to work for us. It's wrong, right? So that's proving to you, the whole point of this is to show you that the JavaScript way of doing dates that we get from Faker is not compatible with MySQL. So let's just see what happens. I guess I can keep this here, but let's see what happens if we go to our app.js and we try and insert a person with a Faker date. What do we get, an error message, or what happens? So we'll do this. I'll make some space here. And rather than just email, we'll also do created at, which is faker.date.past. So the same thing we did down here, which generated this date, but now we're doing it dynamically here with an email and a created at date, both dynamic. We're going to insert person using the same syntax, and let's see what happens. Okay, hold our breath here. Node app.js. And what do you know? We don't get an error. So what's going on? Did it work? Let's come over here. Unfortunately, we're not able to do our, select star and order by created at, because our created at dates now vary. So it's no longer that the last one added in has the most recent date. So we'll just do a select star from users. And what we'll look for, in my case, I happen to know the data that we were working with. This was the one that was just added. Lucio 38. Yours, of course, will be different. But notice that the date time, or the created at, isn't 0000 like we had for Dusty. This was the one where we manually took this, the same exact thing coming from JavaScript, but we did it ourselves and it didn't work. But then when we used person instead of variable, and then we used connection.query and we passed it in, it somehow worked. And basically it comes down to the magic of this library. And I'm showing this to you to illustrate another point, which is there's a lot of work that goes into sewing the stitches between something like Node and MySQL. So if we go to the docs here, if we do a search for, I'll just do date time, and I think it's down. Okay, here we go. If we look, there's something right here that says date objects are converted to year dash month dash day. Basically the syntax we're looking for. They're converted to that. So as part of this library, it takes it upon itself to bridge MySQL and Node. It says, all right, if this is a JavaScript date, which is what we're working with from Faker, well, I know that the user is trying to insert it into a MySQL table that has no idea about JavaScript dates. So we're going to convert it before we send it. And then one other kind of interesting thing we can do is save this to a variable, and we'll call it end result. And if I just do a console.log end result.sql, which again, all new stuff, I know it can be overwhelming. What this will do is show us the compiled SQL that is being sent over. So this is kind of before what person looks like, and this will be an after. And let's take a look. Well, we have to go to Node. Okay, so you can see before we had created at, looked like this. Tuesday, May, it's a wrong format. That's JavaScript format. But sometime before we actually sent this over, it was converted to created at is equal to 2016-05-24, and this is the correct MySQL syntax. So this is kind of cool to be able to see the end result SQL that's being sent over. This is, valid SQL that we could just copy this over. And yeah, it might look slightly different. These are escaped, which you do not have to do. But if you notice, this is SQL syntax, and we could just paste that in. Okay, so I'm going to get rid of that, but I just wanted you to see that you could do that. And more importantly, the whole point here was to show you that there's stuff happening behind the scenes, which can be great and useful, but it's also, there's stuff that you just don't know what's happening sometimes, and you run into it, you discover it. But it's the job of these libraries to connect the two, and there's a discrepancy in this case between how JavaScript handles dates and how MySQL handles or expects them. So behind the scenes, this library that we're not writing, we're not in charge of, somebody is, that library is patching them. It's fixing it for us. Okay, So we've inserted a single user. Now all we have left is to figure out how we insert 500. That's the next video. All right, so we're finally at the end of this section where we're actually going to insert 500 users at once. And you'd think that it'd be easy because we already saw how to insert a single user like this, create a single object, pass in email and create it at, and we just pass in that single one. But then we have to worry about, okay, well, if we're trying to do 500, technically what we could do is repeat this entire process 500 times. But there's a better way than that, because if you think about this, every time we're running a query here, that's 500 separate queries, inserting one at a time individually, which is not ideal. What would be much better is to generate all 500 users at once and then do a bulk insert, insert them all together, like this. Here we inserted 2, not 500, but this is 2 people being inserted where we're passing in a list. Now this is MySQL though. Now the way we do that in Node using this library is a bit different. So I'm going to show you, I dug through the documentation and found out how to do a bulk insert. Rather than passing in a single object like this, what it's actually expecting is an array of arrays. So something like this here. So I'll show you a better example. We'll actually do it together. But rather than giving it an object, here is an array called data. Inside of it, 3 separate arrays. The first thing is an email. The second thing is created at. Then the query that we're doing is now insert into users, and we actually do have email comma created at, our traditional syntax followed by values. And then this question mark will be replaced with whatever comes after it, which is data. So then it will take this array here and it will stick it here. And basically it will insert each one of these as its own row. So we'll say this is email, this is created at, insert that. Here's email, created at, insert that. So this is the JavaScript way of bridging that gap. This is how it's done with this library. And this is why it gets wonky and weird when you're working with other libraries and other languages where they don't, the syntax is different. They don't support the exact same way that you would work with MySQL. So it's kind of weird, but once you do it and you have it done, you can just refer back to the code you previously written. So let's test that it works first. Okay, so we had inserting data take 2. I'm going to comment that out and move down to the bottom, inserting lots of data. Just make this a little easier to see the division. Okay. So rather than just, we can leave it as blah at Gmail, I guess, and ugh at Gmail and meh at Gmail. So we have this array of arrays, only 3, but the difference between 3 and 500 is basically nothing. It's the difference between doing 1 and 2 that we're trying to get around right now. We saw how to do 1, so this should be easy once we get 3. So we save this here, and let's just make sure that it works. I'll also add my connection.end. And we'll make sure everything else is commented out except the connection part. And we'll run it from our app over here. Okay, it looks like 3 affected rows. That is good news. That means that they were inserted. If we go over here and do select star, we can see meh is in there and blah. And where are you? Ugh is at the bottom here too. So this worked. This successfully entered or inserted 3. The syntax is weird. I totally agree. It's different. I totally get that, especially if you're new to JavaScript. This must all be overwhelming. Don't worry. We're going to get through it. We're going to make the app. But what I want to show is that, again, it's different. You have to be prepared to kind of play within the rules of whatever language you're working in. Okay, so we've got this, but rather than these 3, what we really want to do is generate an array with 500 entries. And each one is going to have a faker email and a faker date. So to start, I'm actually going to make data empty, just like that. And all we would need to do to add in our first fake array would be data.push. And push will just add to the end of this array. It will add inside of it whatever we tell it to. So we want a new array. I'll make some space here. And all we want to do is push in 2 things. The first is faker.internet.email. And the second thing is faker.date.past. So what this will generate, if we just do a single one, and do a console.log data, and don't do our query here. Comment that out, and we run it. Wrong terminal. If we run it, you can see, all right, it did it. We've got our first result in there. So then logically, if we just repeated this and did another push and another push, when I rerun it, now we end up with 3. So we just need to do that 500 times. And we're not going to copy and paste 500 times. We're going to use a loop, and it's just going to be a simple for loop. So for var I is equal to 0, while I is less than 500, add 1 to I. So we saw one of these earlier. If you're not familiar with JavaScript, these are the bread and butter. It's a way of repeating code. So this basically says repeat whatever's inside of here 500 times. So we just pass that in, and this will now run 500 times. Each time it's going to generate a new email and a new date. It's going to push them into the data array. So we end up with one giant data array. So we can print that out. Let's see what happens. And you can see as I scroll through here, you'll have to trust that it's 500. But we've got tons of results in here, tons and tons of them. Awesome. Okay, so now all we need to do is uncomment this section. I'm going to comment out our console.log, but uncomment the part where we're actually taking that data, which is our giant array full of fake data, and we're inserting it. And nothing needs to change. We have email first, followed by created at, right? If you look at our last one, email, created at. Okay, moment of truth here. Let's try it. Save the file. It looks like 500 affected rows. Look at how fast that was. Look at how short our code to do it was. If you ignore all the white space, it's just this part. Now let's head over here. Let's start by selecting star. Awesome. Look at all of them there. And I'm actually going to drop everything because we have some bad users in there that with, time created at set to 0, 0, 0. So we're going to just do delete from users. 518 of them gone. Now we do a select star. Nothing. But don't worry. We're just going to rerun our code one more time. And so easy, so fast. We now have 500 users in there. Awesome. Okay, so we'll end it here. I recommend that you delete everything and just remake it with 500 exactly. We have a couple of exercises using these. Of course, your data will vary, right? You're going to have different emails, different dates, but it won't matter for the exercises. And once we get past those exercises, we'll move on to working with this data in the context of a web application. So we saw a lot in this section. It's very kind of disparate, fast-paced, I'm aware. If you don't know JavaScript, I can imagine it's quite intimidating, but hopefully the takeaway is not that you're a JavaScript genius, that you could recreate this on your own, but more that you see that we're able to use JavaScript to insert or select from a MySQL database, and that we can do things that we could do on our own, like insert a single user, but we can also do really powerful things that we couldn't do on our own or would take forever, like inserting 500 users that are randomly generated with just a couple lines of code. So this is really our first thing that we've seen that takes advantage of the power you get from using a language like JavaScript. Awesome. Alrighty, so we inserted 500 users. It was kind of a behemoth of a section to get there, lots of ground to cover. But now that we're there, we're back in our comfort zone, hopefully, we're going to have a couple of exercises. I know we have a lot of them, but this is cool. We have a lot of data now where it was, a single, you hit the return key once and you got 500 users, much easier than having to copy and paste like 20 books. So we're going to play around with them. And again, your data is randomized just like mine. So your tables and your results will look different, but the queries will work the same. So here's the first thing. Find the earliest date that a user joined. And all we need to see is the date. And also notice how I formatted it. Pay attention to that. So just the earliest date. And then the next problem, find the email of the earliest user. Now this one's tricky. Remember how we talked about this with min and max way back a couple, 5-6 hours ago, about how when you use min and max, you just get the min, you don't get the row itself. So we had to use a subquery. So the hint is use a subquery to find the email that corresponds to the earliest user. Then take all the users, and I want to see a table where we have a month name and then the number of users who joined in that month. So it doesn't matter what year. We have some 2016, some 2017 most likely. So we're not grouping by that, just by the month. So you have to figure out how you extract the month name from the date and then go from there. Also notice the order. Then count the number of emails or the number of users with Yahoo emails. And the way that you can determine that is just if their email ends with @yahoo.com. So how do you do that? Count them all. And then finally, calculate the total number of users for each email host. And this one's a little bit complicated because you're basically going to be doing 4 different checks. You're going to say, all right, does the email end with Gmail? Does it end with Yahoo? Does it end with Hotmail? And then you need to calculate how many each end with these. So it's a little bit complicated. That's why I left it for last. Hopefully you're able to get it. If not, solutions coming up in the next video. Just remember, your data is going to look different. Don't panic if your numbers are different. All right, I'll see you with the solution. Okay, here we go. So let's first start off by just making a new file to work in. So we have some clean, we'll just call it exercises.sql, just so we have a nice place to put the answers. Okay, so our first one here, find the earliest date a user joined. And we're not selecting anything except the earliest date. So all we need to do is take advantage of created at and use the min operator, the min function. So it's just a matter of select min created at from users. And we'll save that. Copy it, paste it, and the one that I get here looks like this. So 2016 501. Notice it says earliest date, so that's the easier part to fix. And then notice the format. So let's do as earliest date first. That will make it cleaner. Then we need to format the date. So I'm going to put this on a new line. And the way that we format, remember, is we use date underscore format. Think back to our date section. So we're formatting the result of the minimum created at, which is this. And we have a second argument, which is the date string, how we want to format it. And the one I gave you had the month name, which I believe is capital M, and then the day with the suffix, which is, I believe, capital D, and the year, 4 numbers, capital Y. So you need %, capital D, %, capital M, nope, backwards. Capital M, %, capital D, %, capital Y. Let's see. Oh, I have to copy this, paste it in. And there we go, May 1st, 2016. Okay, look, we're only a day off from the first data set that I added. When I made these exercises, I had a different set of data, and you just watched me rerun it, delete it all, create 500 new ones. So these will be slightly different than my answers too. Next, find the email of that user. So the same one that we just found, this was the earliest date. How do we find the email? So let me label this challenge 1. In this one, we have to use a subquery because basically what we're trying to do is, well, first we can clean this up a bit. We don't need to format this one. But basically what we're trying to do is take this earliest date, which looks like this. And then we want to do a select, we'll do an email from users where created at is equal to that date. How do we find that user? So let's just do it manually. It looks like our answer is colebailey@yahoo.com. So we can use a subquery to help us, where all we have to do, we can get rid of this and say select email, comma, created at, or we could just say select star to make it shorter, from users where created at equals, and then we have to do our subquery, select min created at from users. So those parentheses indicate that this is a query that needs to happen. So this is evaluated. What is min created at? Well, I need my parentheses to work there. There we go. What is the min created at? Well, it's going to be this. So then basically this whole thing is replaced by that. And then we're finding users, star from users, where created at is equal to that. So let's try it. There we go. Looks good. We've got email and created at. Of course, it looks different, but this is the correct answer. Cole Bailey. And we saw that because earlier we just manually selected it based off of that date, and it worked. Perfect. Moving on. So we're taking every user, taking their created at date, and then we're extracting the month name from that date, whatever the month is, combining them all, we're grouping them and counting how many exist. So how many users signed up in November. In our case, November was the highest. And then we're sorting as well. So let's start by just extracting the month name. So if we were to take a date like, where is that? This one right here. How do we get the month name from that? Because if we just do select month of that, it gives us a number. So what we can do instead is month name, and that gives us May. So we'll start with that. We'll do select month name of created at from users. And we get 500 different month names. Well, there's only 12 different ones, but 500 rows. So then what we want to do is a simple group by, and let's just give it a name like as month and group by month instead, rather than retyping that whole thing. Okay, so now we have 12, assuming that we have a date in every month of the year, which we probably do if we have 500, but we don't see how many there are. So then we need our second field. And our second field is count. We just do count star, just like that. And here we go, almost there. All that we need to do, I believe I gave this an alias of count. And then we also want to order by count, and we want it to be descending. Let's see if it works. There we go. November had the highest count as well with 52. Although it diverges, January was first, or was second, in my case, May, and then April. All right, so we use this month name, and we group them based off of that month. You could also just replace it with this, but it's easier just to type month, and then we're grouping them, counting them, and ordering them. Let me just put a note that this is challenge 3. Moving on, challenge 4, count the number of users with Yahoo emails. So for this one, it's a bit of a throwback. All we need to do is use like to figure out, which emails have Yahoo in them. So we'll do a challenge 4. Let's do a select star from users, where we just need to say we're created at like, and we don't just want to say Yahoo. Remember, that's only going to find, and what am I saying, created at? Where email like Yahoo. We don't want to do that because that's only where email is exactly Yahoo. So we need these, the placeholders, but we could improve this a bit because this would match anything that had Yahoo in the string anywhere. And we could have someone's email be, yahootim@gmail.com. Or maybe someone's last name is Yahoo or something, Yahoo's. So we don't want that. So all we want to change is we'll do @yahoo.com. And this will guarantee that the string ends in @yahoo.com. So now let's take a look. Here we go. These are all yahoo.com emails. And then all we wanted to do was count how many. So rather than selecting star, we'll do select count star as Yahoo users, I think is what we called it, from users, where email is like Yahoo. And this time there's 170. And finally, challenge number 5, calculate the total number of users for each email host. So this one involves using like along with a case statement. it's a little bit complicated. So we're doing the same thing where we're counting the number of users, but we're doing it dependent on the provider. So we're going to have a case statement. So we'll just start right off with select. We'll do case, and I like to do my end as, and I think we called it provider. Yep. So we'll start with that, and we'll do from users. And what is our case? Well, we can start with this Yahoo one. We'll say when email is like Yahoo, then provider is Yahoo, right? So we'll do the same thing, just basically copy this and say when email is like at gmail.com, when it ends in Gmail, then Gmail. One thing I should note, there is a kind of nicer way of doing this if you are familiar with regular expressions, but that's out of the scope of this course. But if you do know it, you can get by with that. So we've also got Hotmail, then Hotmail. There we go. Okay. Then finally we'll have our else, which will just be other. So we have this provider field now, a column that will have Gmail, Yahoo, and Hotmail, or other. So let's do email comma case so that we can see the email side by side against what we pulled out of it. So we got 500. Let's take this one. Ray.more1@gmail. We get Gmail. Ruben Medhurst at Yahoo. We get Yahoo. Perfect. So now it's just a matter of grouping them together and counting. So we can get rid of email. We don't need to display it. Then we're just going to group by provider, which is what we just created. So let's start with that. Cool. So we're grouping them together. Looks like we don't have any others in this case. We're going to group them, and then finally, we're going to count. After our case statement ends, we add a comma, count, star. Copy, paste. And there's just a small discrepancy, which is this is called total users. Also, this is sorted. Very easy to change. We'll call it as total users. I like to capitalize that actually. And then finally, well, let's just make sure that that works to start. Great. And now we need to sort it. Order by total users. And if we do it this way, you'll see that it's ascending. We want to do descending. All right. Now we've got all the providers on the left and their total number of users. Perfect. All right. So hopefully you enjoyed that chance of working with more data that isn't hard-coded in. Some of it's dynamic, all of it's dynamic, 500 plus users. Next up in the next section, we're finally going to connect the database we just created, we just filled with all that seed data, and we're going to connect it with a web application and figure out how to get those to talk.